the right one I just gave you in the Zoom chat. And then once you go there, you should be able to access it with this information here. You also can just go to slido.com and input the information that I just gave in the Zoom chat. Okay, I don't want to steal any more time. I can pass it over to my colleague, Rich. Really excited to have him here giving the workshop. Thank you, Rich, for all that you do for the open source community. And with that, it's all yours.
Okay, thanks so much, Phil. And thanks everybody for attending. I'm going to share my screen right away so we can get right into it. Great. So the first thing you should see, besides my Zoom and my calendar, is this webpage. Basically, all the exercises are here on this repo, pointblank-workshop. And the link to the cloud project is here. Follow along if you want with the cloud project. It's the same stuff that's in here. This repo will always exist. The cloud project will always exist, which is great. So there's a life outside this workshop for these materials. You can either follow along like in the cloud, like by like executing the different parts of the R&Ds, or you can just watch. It's totally up to you. There's no exercises. There's a ton of material though. So we need to get started. It's a 3-hour workshop. I made, this is the first time it's being delivered. So I'm not sure if it's too much material or too little material. I think it may be hopefully right in the middle, but we're about to see. So any feedback after this workshop would be totally appreciated. Just concerning like the amount of material. Okay, so we have a number of modules that we're going to go through, and basically they are these RMD files right here. Okay, so first we're going to have an introduction into data validation. So I'm going to skip right to that RMD, which is right here. Okay, so we're going to start with data validation, and that's data validation of tables. The whole package just deals with tables, not lists or vectors. So the scope is very much like data tables. So common workflow that we start off with is involving an agent. So what's an agent? Well, it's kind of like the main data collection and reporting object. So you define that, you give it a table, you declare a number of validation steps, and we do that using validation functions. And we'll learn about how to do that. And then we interrogate the data. So that's where essentially we are actually applying the rules that we've set here in the middle part right here. So we're going to see whether our validations, what they yield in terms of like test results. Okay, so we always start with create agent. And that's how we define how the data can be reached, give us some basic rules. We end with interrogate. So the major construction is right here. You create the agent object, start with this, a number of validation functions, and then interrogate. We close with that. And we can use pipes all the way through, which is nice. So in the actual package, we have a data set called small table. It's a really, really small table. I'm going to show that to you right now. It's essentially this. So it's great because there's columns of different types. It has some missing values. It's a great table to experiment with, just when using the functions from the package. So we have that. We're going to use that in the next example right here. So we're going to make an object called agent1, starting off with create agent. The table argument is the first one. We give it small table. This is like a little name for a report. So basically what happens in point blank is you get a report in your viewer, and you can publish this report, or you can just use it as it is. But we can feed it different little things like the name of the table, like a friendly name, and the label for the validation. So this is quite nice to have. So I'm going to do that right here. I'm going to run everything in my console. The reason is I don't want the report to appear here. I want it to appear in this giant viewer area. So I'm just going to mainly copy and paste many times. So I can just type agent1, print it, and the printing actually happens in the viewer. So we see right here, we have, well, kind of like a whole lot of nothing. We have like a title, we have our label that we put in. It knows what table we have, but it says no interrogation performed. It's because we didn't do that yet. So at least it gives you something. So this is like an empty table. Great. So
can I ask you a quick question?
Yeah, please do.
Did you have an RCU cloud for today? I had a question about that. I wasn't sure if.
Yeah, it's right here. It's this link right here. It's inside.
Oh,
this
beautiful. Thank you.
Yeah.
Okay.
Yeah, it's right in the body of
I
that.
see
So you
it.
should,
Okay.
yeah, I can
awesome.
actually copy it to, unless you get there first, Bill.
Yeah, I
to the
got
chat.
it. Don't even
Yep.
worry about it. Okay.
Okay,
Thank
excellent.
you.
No problem. Okay, so validation functions. That's kind of like, like the main thing, the main event when it comes to validation in point blank. So we have a ton of these functions. A lot of them begin with call, but they can be given something else. So how would we read these? So basically this function says we want column values greater than or equal to some value. And we're focusing on column D. So what it'll do is it'll go in each and every cell within that column and check that the values are above 0. This is a different one. This is call vals and set. So what it's saying right here is in column F, we expect that values in it are of this set, right? This predefined set. There's a bunch of call is functions. We'll get into this a little bit later, but it's good to explain it right away. It's just the column type. So we expect that column E is logical. Column D is numeric. Column B and F are character. And we have another function here. It's also a validation function, rows distinct. So we're just checking for duplicate rows. If there are any duplicate rows, that's going to be a failure. Not an entire failure, but like a failure of test units. More on that in a sec. So let's actually run this. I'm going to run it right here. And then agent 1 will go here into the console so we can see it printed in the viewer. Great. Okay, now we're starting to see things more than before. We have basically a test plan right here. We have our functions coming in. We have the columns that we're using. So it kind of mirrors what we have here on the left, what we put in. But we have nothing on the right. This is all empty. It's it's because we didn't actually interrogate the table yet. We're one step away from that. So we're building up the plan. And our next step is just to interrogate. So it's basically this function, interrogate. And then, great, it shows you some stuff on the console, which is good. Kind of like a preview of what's to come. And then agent 1 again. Great. Now we see things. We see that we have stuff on the right, and we have all sorts of data here from the interrogation. I'm going to get into how to read this table. Make it a little bit bigger so we can see more of it. Great. Okay. So there's quite a few things here. So I've got it all written down here, so you have that for reference later, but I'll just go through it pretty quickly. We have the step. Basically, this is a step index, and we have the function that was used as a basis for this validation step. So each row is a validation step. The columns and the values, this is kind of like common for most of these functions. You see rows distinct doesn't have that because it's not so much, it's checking across rows instead of columns. But we have essentially, this mirrors the arguments you put in. This right here, so there's like feature in point blank where you can modify the table in a step. Say you just want to filter it a bit, or add a column, a computed column, and then validate on that. You can do that. This just shows that there were no modifications made. We didn't use that feature. Eval just means that everything was good in terms of the interrogation, the evaluation of the table. Nothing unexpected happened. Good to see. You want to know that things worked before you validate things. So this is very important to have. Units. This is a big thing. So units are these atomic units of tests. So this one has 13. That means there's 13 cells checked in total. 13 individual checks within this step passed. So the fraction of 1, and none failed. So a fraction of 0. The only time we have failures, it seems like, is in row distinct, because we have duplicate rows. So we see that right here. We have some failures. What this does also is shows you in this ext, that means extract. It gives you a CSV of the failing rows. So you can just click that, get the CSV file, and then see which rows are duplicates. This is good for people not using R. If you just want to show somebody this table and they may be somebody else, they're not using point blank, they can at least find out which get the root cause of what's causing failures. So that's pretty much it. These things right here, WSN, these are different states. They're indicators. We haven't set any of these yet. We will. But these are thresholds that that signify different states. So this W is warn, this is stop, this is notify. And if we set them and we get a number of failures, which breaks the threshold, we see that's filled in and we get some indicator of that. And that's a good way of seeing whether things are important. You can act on those things. It's very flexible in that way. Okay, So let's actually use this or make this useful by setting threshold levels. Okay, let's see right here. So basically, we want to use the action levels function to do this. And within that, there's like 3 arguments, which are, you can use any number of them, one of them, all 3 of them, it's totally up to you. And these are fractions right here. We can also include like numbers, like 1 at the first failure. But here we're just using fractions right here. So basically it'd be like this number right here would target under the fail. So we're going to warn at 15% of test units failing per step. I'm going to stop, not really stop, but they'll just indicate in the S column when 25% of test units fail, and notify at 35%. Okay, so this is basically, this is pretty benign because it doesn't actually do any of these things. You could set an action for when each of these are entered with another argument, but we're not going to do that because it's a bit too complicated for this workshop. But we're going to do this at least. So we're going to make that object from action levels. We can actually print it and see the results. It gives you sort of like a indication of what you did right there. So warn failure threshold of 0.15 of all test units. Okay, so this is a default for every single step. And you could, in a given step, change that. But we're just going to run with the default for all test units like this. Okay, so I sort of explained that here. I think I reasonably explained that just earlier. So I'll just skip past that. So agent 2 is going to be very similar to agent, the first one. We're going to have a few more of these like validation functions within, like this regex one, for instance. Yeah, but the key thing that's different here is in actions inside create agent, we're going to introduce that action levels object, which is right here. So let's actually run this. And then I will copy this over here. And we'll see the new report in the viewer. Okay, so quite a bit different. We have more stuff happening. Basically, we have these action levels right here. These are failure thresholds, sort of like as fractional values. So we see right here in step 2, we have a little bit of yellow here on the left, signals warning. And we see that this is filled in right here because we have more, 0.15 of units failing. So we get the CSV as before. This happens when there's any test failures, but we see these when there's a threshold being broke through. Calls vals regex really failed a lot, like almost more than half of its test units failed. So we get all 3 of them being filled in. So we see it's active because we have these sort of like open circles, which means that it's, it could enter these states, but the filled ones means it did. So that's what we have here. So this is good. So this is a good report. And we have these indicators on the left, which are colors, which sort of mirror what we have here. If you see green, like a solid green like this, that means everything passed flawlessly. If you have a lighter green, not everything passed, but we didn't enter any of these conditions, like W, S, or N. Okay, so that's basically how you read the report. And continue down. Okay. So like I said before, you could do, this is a default right here, these action level thresholds. But in any step, there's actually an actions argument, and you can set like a different action levels value for that. So for this one right here, call vals between, we're saying column D should have values between 0 and 4,000. But here we're specifying its own action levels value. And we're saying here, we're using absolute values. We're saying warn at 1 failure, stop at 3, notify at 5. Okay, so let's actually run this. Great, so it's doing this little thing in the console. I'm going to show the report.
Hey, Rich, you got a question you want me to ask those as they come up, or do you want to just wait till the end?
Please do. Yeah, that'd be great, actually. Yeah.
Okay. Someone asked, is it possible to change the report title if you want to share it with colleagues?
You absolutely can. Yeah. So I'm going to do that right now because it's a good thing to do. So it's basically get agent report, and there's a field there called title. So by default, it's called default, but you just give it any title you want, like my title. And just run that. And it appears there. And there's a few other little keywords that do nice things, like maybe the table name becomes a title, and you can use Markdown here too as well. So another little nicety. I'll just show that. It's not incredibly obvious. There we go. So that's bolded now. So yeah, definitely you can do that. You can customize with get agent report, but by default, just printing out the agent itself, you just get the defaults, but it's highly customizable with this function. Okay, so continue on. We have this now, and we see that call val is between. Yeah, it's between 0 and 4,000. This changed. So basically, right here, there's one test failure, but it signaled a warn because we set here, warn at equals to 1. So that's different than the rest. We don't really get an indication of it, but we just kind of know from our code, I suppose. So that's what we can do. We can customize per step or just have defaults that run through all the steps. Okay, so I'm going to skip past and I'm going to give you a brief look. I can't describe all of these validation functions. There are certainly a lot. There's 36 of them. Suffice to say that they do have really detailed help articles. If I go to any one of these, like call vals between, for instance. Oops, I typed it wrong. There we go. So they have very long help articles, and each one, they're not lumped together in terms of like there's lots of these in one help article. Each one has its own help article. And the good thing about it is that it does have examples which are fully worked out. And there's actually images as well, showing you what you expect. So these are totally runnable. I try to make the examples in a way that, it's like a mixture of prose and the example itself. It shows an image. So, if you land here, you kind of have something to go by. Okay, so there's lots of these basically. And I hope it covers most of the common checking scenarios. If you find one that doesn't quite cover it, there's actually one called specially, which allows you to just use any function you want and sort of like go manual as it were, but it still appears in the report, which is kind of a nice common ground or middle ground. So there's lots of them, but they can be described as sort of like groups. You can see there's some commonalities in the names. So I'll go through that pretty quickly right now. So the validation functions that begin with call vals, right here. What they do is, and it's what you've seen, they check individual cells within one or more columns. And here's a nice little tidbit that you may not know because you're just learning this right now. You don't have to use an agent. I mean, you get the report and everything, but you can use the validation functions directly on the data. And if you do that, it acts like a sort of like a validation filter. The data will just pass through unchanged if the validation passes, but it will error, like truly error, if it doesn't pass. So let me show you that. So a small table as before. I'll show it to you in the console again. So we have a reference here. Make this a little bit bigger. There we go. So call vals between, focusing on column A, which is right here, the integer column. We expect that values are between 0 and 10. And they really are if you just take a look at it here. So you run this, you just get the data. Okay, so if you choose like something that's not correct, between 5 and 10, there's definitely values less than 5. So let's run this. You get an error. And you get an explanation for the error too. You see here it says exceedance of failed test units where values in A should have been between 5 and 10. That's what you wrote down here. But really you got like 10 failures in this whole thing, which is quite a few. So it's greater than the failure threshold of 1. So automatically the first error will cause a stop. You can set that with threshold. It's like a simple version. Actually, no, it's action levels. But you can actually use actions here if you wanted to and set it yourself. I won't do that for sake of time, but it can be set here. Okay, so another one
questions
is
real quick, if you want to tackle them.
Yeah.
Awesome. First question is it possible to build a new validation function?
It is. Yeah, it is. It's not easy. You might want to take what you have in terms of the available validation functions. I guess like these are considered as primitives. But also you can do it, there's a few ways. It's not so easy to describe quickly, but you can use something like call vals expression, name your function as the thing you want it to be called, and then like use this internally and then provide the expression there. That's one way of doing it. Another way is using specially. that also takes a function, but it does it in a different way. It's more like loose. It's more like more forgiving. It does less checking of the existence of a table, for instance. And you can wrap that in your own function and then set a few things. So you can definitely do it. And I think one of the answered issues in the point blank repo has some examples of this. Unfortunately, I can't really dig those out right now. But it's been asked before, and it seems to be totally possible. Making a whole brand new one that ties into point blank and uses all its features, that's not so easy because it's really sort of like intertwined with all sorts of reporting things. But you can definitely use it by wrapping one of these or one or more of these functions to make a sort of like a special one.
Awesome. Awesome. There's another one here. As I think there are no factors in the example, any comments on how the package works with factors?
Yeah. It doesn't do a great job with factors because that's a bit sort of a special thing. Yeah, I mean, you can use like these special functions like specially, which we're not going to get into, and also call vals expression, where you can pass your own expression and you expect to get like a vector of like true, false. You can definitely use that. But things like, the other ones where, you're checking like ranges, I'm not quite sure actually how that would work. But if you do use it and it doesn't work, they pass me an issue because like that part hasn't really been addressed as well as it probably could be.
Awesome. One more. It says that we may get to this later, but is it possible to check for something like specific proportions adding up to 100%?
Yes. Yeah. To do that, I would recommend making like a metric, like using basically creating a different column. You can do that in any of these functions right here. Like say, for instance, okay, maybe we could just do that right now. We can rattle that off. So we have create agent, and then we pass in small table. Yeah, and then we want to check that something equals something, like proportion. So let's try that. Small table, we do want to do call vals equal, for instance. And we don't have a column like that where we can actually just add it up and get like 100. But let's pretend a bit just to see the concept here. So let's find out what this does here. So call vals equal, and then we will do columns. We'll make a new column. So we'll call it X, and we'll do preconditions. And I believe you can do, maybe we won't call it X just because it's the name. Okay.
Rich, there's quite a few questions are coming in the Zoom chat. Do you want to take a look at those? Or you want me to read them to you or keep going and come back to them?
Maybe keep going and come back to them.
Okay,
yeah.
Beautiful. Okay.
Yeah. So I'm just going to find out how to use preconditions. Okay, so it's basically like this. Okay, so we can do something like we can mutate. Just get rid of that extra tilde. Great. And then in this case, we're using mutate. And we'll say y. Well, we won't actually do the thing that was asked, but we'll do something similar. We'll say like y will equal a plus 10. Okay. And then we want to see that values are maybe greater than 10. So let's do this. Value 10. Okay, so we have to interrogate. Okay, so what we're doing here is we're actually making a new column, y, and you could do like a summary and try to get all the values in a column and make like a table which just has one row and maybe that one column, and then check if it equals something. In this case, we're doing something totally different, but the concept is kind of the same. You're taking like preconditions argument, you're mutating the table, you're making this new column, and you're checking that column at the same time. Okay, so it's like two parts that sort of like go together. But once you get that idea that you can like sort of like at any step you can like change the table and then check that changed table, that's kind of nice because like you don't have to have a whole bunch of functions that check every little tiny thing. You can make the metric and then check that new metric even in just like one step. You just got to be confident that the change you make is correct. I hope that somewhat answers the question in a roundabout way. Okay, but I'm going to carry on, and I'm going to move on to like these call is functions. Basically what they are, and we've already seen them, is a column is of a certain type. So call is character, checks for a character column, and you know the rest. So that's what that does. There's two rows underscore functions, rows distinct and rows complete. They check for entire rows. We've already seen like rows distinct. It just checks for duplicate rows. If there are any, that's a failing test unit. Or it could be as many like test units failing as there are duplicate rows. Rows complete just checks every single row and looks for NA values, right? So if there's any NA value, then it's basically a failing row and a failing test unit. Okay, so let's check these. We know we have like duplicate rows in this table. I put one in on purpose. It's basically rows 9 and 10. So if you actually run this, we get an error automatically. If you just take the head of the small table, which avoids the duplicate rows, it works fine. We just get the data out. Because if you apply these validation functions directly on the data, again, it just passes the data through. Okay, rows complete. We know this fails because we have an NA somewhere in there. Tells you that right here. If you just take a few of the columns, you could, in the columns argument of rows complete, constrain the check to just a few columns, which is kind of neat. It's same thing happens or is possible for rows distinct. So if you just want to check 1 or 2 ID values that they're unique, you can do that with this function, or with that argument, I should say. Great, so that passes it through the whole table. We just checked date, time, date in A and B because there's no NAs there, and it works. Okay, there's a number of match functions. These are a little bit complicated, or at least some of them are a bit complicated. I will show you 2 examples here of row count match and call count match. We're just checking that the count of rows for the entire table it beats an expectation. So we know a small table has 13 rows. If you run this, it passes fine. And another cool thing is in count, we just pass in another reference table, and it just looks, we're just matching the count of columns in this case with that of another table. So it just so happens that small table has the same number of columns as Palmer penguins. If you run this, it passes the data through because it's true. Okay, so that's my super quick look at all the validation functions. Each one of them has a help file with examples that work and are pretty instructive. It's really hard to get at them. Each one has a different interface too, depending on what they are. They may have different arguments, but they share a lot of common arguments. Okay, so getting data extracts from the failed rows. Okay, so we've seen before that, if you go back a bit, we have these CSV buttons here. These are all fine and well, but we have R here, so we can just get them, through R and actually get the, the data frames. And we can do that with get data extracts, that function right there. So let's use get data extracts on Agent 3 and see what it does. And this is a case where I want to expand the console a bit. So we get a list of data frames or tables, really. What we see here is like the name, 2 and 3. These are the step indices that had failures. Okay, so if we don't see 1 because it had no failures, and we don't have any extracts. So yeah, so we get like 1 extract per validation step that had failures. Sometimes it's just one thing. Sometimes it's a number of rows. So this is very useful when you want to find out where the error is for a certain step. That's great. And if you know the step, you could isolate to that. You can just say like get data extracts, same agent, but step 9. Okay, so let's run that. It's kind of cool. We just get the table out that way. The only key thing is you have to know what step is what. But if you know it, then it's kind of useful to use this. Okay, so basically what we're doing in this phase of like the module is we got an agent and we're doing stuff with it. We have a report, that's great. But we want to do things, with the data that's in the report. There's actually tons of data underlying the report. So one more thing we could do is getting something called Sundered Data back. I definitely use a thesaurus for this one. So basically, when I made this function, basically what this does is it splits your input data frame or whatever table into two parts. The pass data piece, basically no failing test units, and the fail data piece. So if some rows had like failing test units, that row is automatically sort of like listed as like a fail row, in a way. Even if there's like no test on it, it'll still be pass. So basically the differentiation is if the row had failures, then it's part of that fail extract or fail piece. And otherwise it's part of the pass one. Okay, so let's actually, it's really hard to describe, much easier to show. So let's actually do that. So here's a new agent making, it's agent 4, pretty simple. We only got 2 validation steps inside. Column values greater than 1,000 for column D. Column values between, this is kind of cool, 2 different columns. So we can do a cool thing like, for like the value, we can actually reference a column and say like, okay, so the values in column C should be between the values in column A and column D. And you can do, literal values, you can mix and match. You can have a literal value here, a column value, a column reference here, or vice versa. Okay, but let's just run agent 4, this validation. We're doing all 3 steps, create agent, validation steps, and then interrogate. Okay, so we see this is great. I'm just going to type in agent 4. And we get the default report. Looks pretty good. We didn't set any of these like action levels. Totally fine. We're not really looking at that. But yeah, we see this. We get some failures in both steps. Okay, great. So now we're going to do a thing where we take this agent and we use the get sundered data function on it. Okay, so what it does is, well, by default, it gives you the rows that pass, like the good data piece. Okay, so these are basically from those 2 tests, the only pieces, like the only parts or rows of the table that didn't have a failure. Okay, you can change that around. Like I said, that's just a default. You can just get the fail piece as well by saying type equals fail. Okay, so these rows should add up, right? These sets of rows, they're also exclusive. These rows should combine to make the original data set. So that's a promise from the package. You can do different things too. You can also have a combined view. What that does is gives you like another column. We call it PB combined. And it's essentially like a flag column. It tells you whether it passed or failed, which is kind of cool. Sometimes you just need to have the whole data frame and like this column right here. And nice thing is right away, you don't have to accept what this is, like in terms of the values. You can set different things. You can set a pass fail vector. And so in this case now, pass will be true and fail will be false, and the column will be changed to logical, which is kind of cool. And also, it's pretty flexible. You can choose integers as well, as long as you have 2 values and the first one is pass, the second one is fail. Then you got this right here. And you can switch these values around. So that's what this does, get sundered data. Basically, it allows you to split the data in case you want to use the data. You did some tests, but you just want to get like the data that didn't fail any of those tests. There's probably some situations where that's pretty acceptable. Okay, Phil, this is not a bad time for more questions because I covered a lot here. If there's any that relate to this, or maybe they don't relate to this. Okay, if you're not there, I'll just keep going. Okay, so we have another function called get Agent Xlist. Again, it uses an agent object, just like those past 2 functions did. But this is kind of like when you just want to get at the information, like that sort of gold mine of like interrogation info. And like, do your own little investigation independent of this table, which is useful, but sometimes you just want the data. So let's do that. We'll make an Xlist by just using the get Agent Xlist function, like so. I'll run that. Great. And I will actually copy this into the console here. And if you do that, you get a printout like in the console of what's in the Xlist. It gives you, it sort of echoes back, its small table. you're basically looking at all steps. That's a default. You can look at individual steps too, and some of the arguments of this function, get Agent Xlist. But we're looking at things holistically. So this is kind of cool. It gives you like all the components of the list. So I can do $ and look at n, for instance. Okay, that's autocomplete, but I won't do that. So basically, that's the number of test units. And failed. You can look at that. Great, just good. You can look at warn. Basically, so this is kind of cool. So you can sort of see if there's any warnings at all just by wrapping with any. True, there were. And the same thing with fail as well. I believe that's right. Oh, sorry, stop. There you go. So something stopped. So yeah, this is pretty flexible, has tons of information. The help file for it explains what each of these things are, each of these components. But basically, it gives you everything that you have in this compiled visual table in a sort of data-centric form, which is useful for programming. So that's what get Agent Xlist does. Here's some examples right here that pretty much are the same as what I did here in the console. Okay. Yeah, and you can do cool things. You make, like, this is an example of like taking this and making your own little mini report right there, if you want to do that. Okay, so that, yeah, sky's the limit if you want to, like, look at what happened during an interrogation with this function. Okay, we'll keep going. And
Rich.
Yeah.
Hey, I'm actually helping Phil to run the workshop.
Hey.
There are a couple of questions. Do you want to address?
Yeah, sure.
Okay, you want from the earliest one or the most recent?
Yeah, just give me a random question, I guess. Yeah, maybe earliest. Yeah.
Yeah, all right. I think one of the early on questions is, I think the comment is it seems there's no factors in the example. Any comments about how to package work with factors?
Oh yeah, I think I answered that pretty badly. Basically, I don't quite know what the effect is. I mean, it's going to be a little bit. Yeah, I mean, okay. Basically, I don't really know. That could be a little bit unpredictable based on depending on what the factors are. There's no functions really that deal explicitly with the factors. They mostly like expect either like integers, numbers, or like just text and strings, or logicals, as it were. But there's nothing really specially for factors. So you have to sort of like custom make your own function if you find behavior which is not like fitting what you expect.
Got it. Thank you. Next one up is in the validation, can you save output files that document the errors automatically?
You can export these reports, for instance. So if I were to do, for instance, like this, sorry, I'm trying to get back to my history. Okay, so Agent 4, we can use functions like export report, and you can export that to HTML, which is kind of nice. So you can like just take that HTML and embed it in Shiny or whatever. You can also just publish from here as well. I mean, the button is right there. But also these fit nicely in our Markdown documents and also Quarto documents. They have their own nip print methods. So they will go nicely in line with those types of reports. So they work great in Connect. They work great just with one-off, like HTML rendered, documents as well. So there's a bunch of ways we can get that out. And another way is email. That segues nicely into my next little bit.
All right,
so I'll just go from here. We'll have more questions at the top of the hour, I think.
Okay.
So basically, so email. So you can create an email. Sometimes you want to be notified if you have errors, especially if like this type of validation is done like on a regular basis on data that's coming in. And you just want to be on top of things. It's really good practice. So you can do a sort of like a small programming paradigm like this, where like, if you run if you do a run and you get an agent, you create an Xlist, you can do something like this. Notify, true. Okay, so that's great. So now we can actually act on that. We set a threshold for notify. Let's do something that, is notifying. So we can actually create an email. So let me show you how that email looks. I'm just going to like run this separately. This is not set up. You'd have to use Blastula, another great package, by the way. But this will create the message body for Blastula. And then you can like take it away with like, putting in your mail credentials and then sending it to whomever you want. So let me just show you what that email looks like. Okay, Agent 3 is obviously very big. Okay, here we go. So it'll do this stuff for you automatically. It'll just generate some little text. You can change all this stuff. This is all very customizable, but it'll include a pretty stripped down version of the table, just with the essentials, units, pass, fail, the states, and then, stuff like that. So this is a message body that can go into, well, it's basically, it just makes a blastula object, and then you can just send it off. This is customizable. Like I said, you can do things, I'm not going to get into it, but you can just expose what failed and not the stuff that didn't fail. So there's options for all that. Okay, so I'm going to get into more customizing, but actually showing it. So the title of the agent report. So I showed this earlier. I'm going to show it to you again. Basically, this is changing the title. We can use Markdown. So we have the double stars on each side of the third, puts it in bold, and we can do other things that are Markdown, like backticks and underscores, things like that. So that's nice. We can also, this is the thing where I'm customizing the report just by like things that failed. Sometimes you just want the bad news. So we're going to arrange by severity. That's one of the keywords. It's all in the get agent report help document. So basically, it's not excluding the, of course, you can do that, the steps that didn't fail, but it's putting the ones which did fail at the top in order of severity. So the ones that, have stop are first, then just warning are the second group, and then the rest. So that's great. So right here, keep fail states. So this is where we exclude things which are not failing. Okay, so let's run this. So still arranging by severity, but we're basically excluding all the green rows. Okay, sometimes you just want this just to get down to it. Oh, another cool thing. Since this is a package that can be used all over the world, we have a lang argument here. So if you do get agent report lang de, and then just run that, we have things which are, in this case it's German, but there's a bunch of other languages too. I think there's 11 languages included. And so it should have little explanations, which, focus on each of the things right here. You can sort of see this is great because like sometimes your stakeholders don't know English. And this is meant to be shared. So that's a kind of cool thing. Okay, so to summarize, I think the timing is pretty good for this first module. I thought it'd be like too long. Questions, of course, I will handle, but this is not bad. This is good pacing, I think. So to summarize, so data validation in point blank, you need an agent, you need a bunch of validation functions and interrogation. It's kind of like a sandwich, as it were, of validation functions. Okay, and the agent, what it tries to do is create a report that's informative and easily explainable. At least once you get the basics, this is pretty explainable, I think. We can set data quality thresholds with the action levels function. And so with that, there's default DQ, like the data quality thresholds, and we can also set step-specific thresholds. Okay, there's 36 validation functions, having a similar interface and many common arguments. They can be used with an agent or directly on the data. And remember, if you use it directly on the data, that's a totally different workflow. You're basically just like probably running it in a notebook and you want it to fail if one of these validation steps fails. So that's the difference there. The agent gives you the report. There's no failing of that, during the running of it. We can get data extracts, and these data extracts are pertaining to failing test units. And these are mainly with cells in a row that fail. And also like duplicate rows. It'll show those as well. So that's extracts. You can use get data extracts with that to get those. You can get splits of the original data set. It's kind of like a different type of extract, but it's like basically two tables. You can choose one or the other, or get a unified report. It basically just deciding which rows had failing test units, and that's like giving one part of the split. The other split is either no test or passing. Okay, get Agent Xlist. That gives you like essentially a list. If you print it, you get sort of indication in the console of what components are in the list, you can basically access everything that's in this report through that list. So you can go at it more programmatically. Email is supported through the Blastula package. Email create is one way of doing it. It gives you the message body. You just pass it to Blastula. So long as you know that other package, connecting it to isn't so bad. And again, the report, it can be modified in lots of different ways. I didn't get into all of them with get agent report. Okay, so that's the beginning, or sorry, that's the end of the first module. I will take any more questions you have if anyone's available to ask them to me.
Yep. Rich, I will
Yeah.
get going with the question remaining. All right. I
Thanks.
think one of them is, I think just starting from the earlier one.
Yeah.
Do we have a check that can check something like the specific portion adding up to 100%?
Oh yeah, I did answer that. Yes,
Oh,
right.
sorry.
Basically, yeah, you can do it with preconditions. It's an argument that's available in all validation functions. Basically, how it works is you create a new column. You can make a summary of the table. The table can be totally reshaped, have different columns. It's totally fine. It's very forgiving, as long as you reference the column that's in the new table up here in columns. So my recommendation is for tests which do some sort of create some new data, or you need to calculate something, I would use preconditions for that.
Thank you. Next one is possible to compare validation errors with each other from one analysis to the next.
I will get into that later. So that is a report, which is sort of like you have maybe the same target table and you have the same steps or maybe slightly different versions of the steps, and you're comparing across different runs or maybe different time periods you're doing the same check. That's totally possible. That's a different type of report using a multi-agent. I will get into that a little bit later in the workshop, but it's possible. Yeah.
Great. All right. Can the validation include a combination of several columns? Like if A isn't missing, then column B isn't.
Yes, there's a function for that. I'll go to the help. I won't really show an example because there are examples in there. It's called conjointly. And you're providing multiple row-wise validations for joint validity. Basically, you want to check that things are true across, right? Like this has to be true and this has to be true. Pass. This is true. This is false. Fail. Any one failure will trigger like that. And if it's something more complex, we can definitely do call vals expr right here, or help document. Does the column data agree with the predicate expression? So basically, I have some examples down here of that. And you can do more complex things like it has expression like, is this correct? And you can definitely involve more columns in that. So you can definitely make something a bit more, like this in this case, like, well, it's hard to explain. You can use case win, for example, and do multiple case-by-case things. So you can definitely get into more complex stuff, which involves multiple columns, and they all have to work out with this. Great.
I think coming up a few questions related to extraction. So one thing is, how does the tools working with big data?
Okay, yeah. So maybe you have a giant data table, like millions and millions of rows. So the extracts have a limit. So that's not really, I didn't state that. There's a default limit of 5,000 rows. So if we go to interrogate, I'll show you where that lives. Basically right here. Yeah, right here, sample limit right here. So that's what that means. By default, we extract failed, true. You can shut that off if you want to. You can change the way the extracts are gathered as well. But we do have a limit. So it'll actually pull or collect those values from the database. And it won't, kill your connection with extracting millions of rows, which I think this is sufficient. You can change this, obviously, but a limit is a good thing.
Got it. I think this kind of answers a similar question as maybe setting a sampling percentage. Can be done?
Yeah, there's a frac. That's a pretty much a percentage.
Yep.
Yeah, so you can set that to 0.1 or whatever. Yeah.
Yeah, and I think another one is, can you actually name the data extract in each step?
Oh, I see. Yeah, instead of just I, like a number.
Potentially.
No, not really, not right now. Not so easy because like you don't really know what steps you're getting. Like there's no great unique name. I mean, it's going to be well, okay, hang on here. Because in each validation step, you could set a label for it, but the label is more like not like an ID. We do have an ID here as well, but it's tough to do in that list as well. But if you find that you rather have like, like get extracts, provide everything by step IDs, which definitely are collected and they're made for you if you don't actually set one yourself. I would say provide an issue, and then we can have like a switch in get agent extracts to either name them by like, step number or step ID, and you can definitely fill that in. I think that would be good, but yeah, currently we can't really do that.
Great. I'm trying to read a few more just pop up from the Zoom.
Okay.
Can the test name be relabeled to show a string description instead of an R function call?
Yes, well, sort of. There's a hybrid approach there. So we can do a thing where we insert a label right below. This shifts up, but the label will appear and will take as much as 2 lines, I think. So definitely you can do that. Do I have an example here? Not really. Can I whip one up fast? Maybe not really as well. But let me show you where that lives anyways. So like call vals between. So you would use it right label right there. So I'm not going to do it, but this is like, descriptive label.
Yeah.
Okay. There's also another thing called briefs, which you can make as long as you want. It automatically generates one for you. That's what you're actually seeing here. Expect that column date time is of type POSIX. You can write a really long one here if you wanted to, but it automatically generates one for you. So it's like 2 places. One is like a label that'll appear right here, and one is a pretty long text, which is by default automatically generated, that you can just have and programmatically extract later.
All right, 2 more. I think we're getting to the end.
Okay.
How would you select columns from a data frame to include the data extract reports after validation?
How would you choose which columns are? Oh, which
Or how
are
you select
used?
columns from the data frame to include in the data extract reports after the validation?
Yeah, I think you can't really do that. I think by default, it will just include the entire row with all the columns. I believe get data extracts does not do that. But what you can do is when you do get data extracts, you can use an lapply and just like select certain columns. You have to be a little bit careful, but you can apply through each of the list components and just do like a sub-selection or a subset.
Okay.
Not very satisfying, but yeah, that's one way of just getting around that.
All right, final one. Can I parallelize the validation using more than 1 core?
I believe you can. Oh, the validation itself. Oh, no, that's something that I should probably be doing if I were, because I think that's not possible. They are independent of each other, which is great. But there's I can't see any real means of like, like splitting it up and then recombining it in the end in a parallelized fashion. Really, if speed is a big thing, and it might be, especially if huge amounts, then I would maybe file an issue, and I can take a look into some parallelization. There's some things which maybe not this, but some other things which should be parallelized in the package. But these are generally pretty fast. With the database, though, it might be a bit slower, but we're not doing anything very complex when we do queries on a database. They're pretty simple operations.
Thanks, Rich. I think that's the end of the question that I can find at the moment.
Great. Good. Should we have a short break? Maybe like a 5-minute break, just to like decompress, maybe review this.
You're the host, your call.
Okay, let's do it. Let's do it. So 1:05 Eastern time. No, let's do it 1:06 Eastern time. We'll recommence and scan your data, the next module.
Thank you.
You're welcome. Okay, I think we could resume. Go into the next module. The next one is called Scan Your Data. It's going to focus on two functions. The first one is what I'm running right now. It's called Scan Data. So what is that? Well, it makes a table scan. So what is that? Basically, you got a new data set. You want to understand what's in that data set. And well, Scan Data can give you that sort of rundown of what's in there. I know in R, there's a ton of packages that do this stuff. This is just one more that does the same thing. But I'm hoping that this is pretty good and it fits your needs. I mean, like it kind of like it goes in with, it pairs nicely with data validation because you have to sort of understand your data, get the lay of the land, as it were, before you really get down to it and like create validation functions. So this is kind of nice. I'm using from the Palmer Penguins package, the Penguins raw data set that contains more data than just the Penguins data set. So basically what it shows me right here at the very beginning, there's like a section report. It's all in HTML. You have sections here we can just go through. We can see when we ran the report, you get some like, environment information here. Understand how many columns and rows we have, how many NAs, column types. It's a brief summary of the table. And then this is really cool. You can go and toggle these details and see like for every column, what's going on. Like we even have like little ggplots being made. So sample number, this is not going to be that exciting, but we do have for some things which are, for instance, numerical values, we have some stats. Here we go. So column length, millimeters, toggle details. We got some, serious stats here in these different tabs, which is kind of neat. So we can really understand whether things, how the data is arranged, what it looks like generally, but also we can find some errors. If things really creep out, you may see a maximum that is kind of like, not right. Of course, in this data, we don't have that, but, who knows what you'll find. And that can be the basis for creating validation functions in your, validation checks. So I'm just going to skip through this a bit more, but essentially it's kind of like this. So it knows about different types of columns and it gives you a different display based on those. We also have this interactions table. It's kind of like just a nice sort of correlation plot. And you can mix and match, character values and factors, with numerical values, and it does its thing, makes density plots and things like that. So kind of neat. Correlations, it's good to have as well. You can sort of see really quickly what correlates with what and what doesn't, and what anti-correlates. Missing values, this is kind of like a little plot, and it shows, which columns have lots of missing values. So, this is like a fraction of missing values in each sector. So each one of these like little squares is kind of like a bundle of rows, or a bundle of cells really, because they're split up. And we can sort of see here that, comments, I mean, not too many comments. So that's, mostly empty, 84% empty, but you can sort of see it right there. It's kind of nice. And here you can sort of see at the end, we're getting a lot of missing values right near the end. So interesting, sort of like, and see here that blue, no missing values at all, not even one. So that's what this shows. Sample just gives you a little table, gives you the first 5 rows, last 5 rows, and it's kind of nice just to sort of see the table, so you have some context about, in case you forgot. So that's scan data. It's kind of cool. And you can customize the report. You don't have to have all the sections here. The default value sections is basically this like little string that's glommed together. Each of these letters represents a different part. You can just change that, change the order even, just by the way you present the letters. And then, arrange the report that way. So you can have as little or as much as you want, different order. It's totally fine. So this is kind of cool. Safety data. So we have this data set right here. I'm just going to look at it quickly. Just a lot of columns, well, a lot of variables. Okay, so let's actually run this. So we just want sections, overview, sample in second, and then variables last. I'm going to run that. It's kind of nice because it gives you like a little rundown of what's happening. This is probably a good candidate for parallelizing because the variable section is a bit slow. And that's totally on me to make faster, but it does, again, a lot of stuff, like a lot of ggplots, a lot of sections, a lot of HTML being generated. If it weren't for HTML tools, this probably wouldn't be as easily made, but we're using that to sort of generate the report, sort of a bespoke report, as it were. Okay, this one's taken a while, so we'll just continue with this. While we wait, I'll just describe that. Yeah, with scan data, you can present the results in different languages. I had a lot of time on my hands, so I was able to translate a ton of stuff and like make all these different languages. Like basically all the little labels that we have here, like sample, will be translated to those languages. So kind of cool. Okay, so that one took nearly a minute. Hopefully it doesn't take very long to show. That's a viewer thing, but we can keep going. Oh, no, here we go. Okay, so safety data, Adam ADAE. Okay, great. So we have the same report. I guess the thing I want to show you, okay, there's sample right here. So it can handle a pretty wide table. That's totally fine. But the thing I want to show you is, oh, look at this. If we have labels in a data set, it shows a label, which is kind of cool. That's not too often in most data sets, but I think every single Adam data set here has that. So that's kind of cool. It's kind of a nice thing. We have that in there. So cool. So it supports that. That's been the only other thing I want to show you. Character, string lengths. It's kind of neat. You can sort of see this. But I won't go too much into that because I believe we covered that before. Okay, great. So kind of neat, we can do that. I'll make one more table scan just to show you something you can do with this. Well, really, there's lots of things you can do with this. This publish button is here again. So we can publish this to lots of places. Our pubs, if you want to go that way. We can publish it to Quarto, Connect. This is all very publishable. We can remove this top navigation bar. That can be totally removed. I think I did that earlier right here. Nav bar false. So you can customize it that way. I've even done things like putting this in an iframe and including it somewhere else. That's totally possible. So it's pretty flexible. It's based on Bootstrap. And it's useful mostly for like interactive things, but it can also be shared. Okay, so let me show you this table scan. So I saved it to an object right here. You can totally do that. Okay, and this one is based on the dplyr storms data set. So same sort of thing. Okay, but the thing I'm going to show you is that you can export this to an HTML file. So export report, it handles all sorts of different objects in point blank. The agent report, other types of reports you haven't seen. This one. You just give it the thing. It could be the table scan. It could be the agent. It could be like the report from the agent that you get from get agent report. It accepts a lot. And then you give it a file name and it makes a complete HTML file for you. So I have that in the files here. Table scan storms. Just going to pull this up a little bit. You click this, you can open a browser. There you go. It's very shareable. It's basically its own document. Great. Okay, so that's all I'm going to say about scan data. It's a cool function. I'm trying to make that even better. I'm always going to iterate on that and make it more useful. And hopefully I'll get at the speed issue because I recommend getting some tea when you just run scan data or whatever. Okay, so here's a different type of scan, but it's sort of like it sort of dovetails what we did before, which is validation. We have this function called draft validation. So what does that do? Well, what I often do when I don't know what something does is I look at the help. Okay, nice. Draft a starter point blank validation.r.rmd file with a data table. So this is kind of like a magical thing. You basically give it a table. There's not much to it. I mean, it has some of the same like arguments as create agent because it just passes through. But what it'll do is it'll create a new file with a bunch of suggested validation steps. So, and it promises to work the first time. So let's take a look at that. So dplyr storms is the data set I'm looking at. So that's the display in the console. It's got all sorts of things. It's got some, month, day, hour, latitude, longitude, other values. Great. So we'll just pass that all the way to like right into draft validation. Okay. Here's a new concept. When you pass a table into table, you can start with a tilde. So what does that do? Basically, that's instructions on fetching the table. You may have something much more complicated where you actually have to do a few steps like, like read CSV with reader. and then like pass it in. And maybe the data changes, as you're getting it. So what this will do is every time it runs or does an interrogation, it'll refetch the table using this. So it won't be like included right away when you run this, run create agent. It'll run when you interrogate it. So kind of interesting, kind of subtle, basically just lazily grabbing the table just in time. So if you include that tilde, that's what it does. I'm including it here because when I create the agent, it's going to pass that through. And I'm going to run this. In fact, I already did, and it's in the files. It makes a new file, storms -validation, and it gives it a .r as well. Okay, so let's take a look at that. Storms validation right here. I'm going to open that up. So I swear this is what it did. Okay, so it basically it makes this. It provides comments here. Basically, these are the briefs that it auto generates for you, and it just puts them in line. You can choose to not have that. There's an option there in draft validation. If you just look here, like add comments, you can set that to false. And yeah, but by default, it just puts those in line, and it makes all this, and it runs. It's kind of neat. So let's actually run it. So there we go. Agent. Good, good, good. Brilliant. Okay, now we're going to actually run the agent itself to get that report. Nice. And everything you see, it ran perfectly. Fail because it's taking the data as it is and assumes it's like, like a good extracted data. You can totally change all these things. Like this may be, not right. It may be a bit larger, like these bounds. Like these are definitely tweakable. So it gives you like a start. You don't have to like type all stuff in manually. You can just start with this. You can delete parts. You have a sort of like a template, as it were. And a really cool thing with this is that it understands certain types of columns. It'll look into things like it knows that long is longitude. So it knows what the bounds are, even if there's no -180 or 180 in the data set. It just kind of knows like this is longitude. And if there's lat, it knows about latitude as well. There's a bunch of things it does. It's called column profiling. It goes by the column name. It does like another cursory check inside the data. And if it all kind of looks like it is what it really is, like what it expects it is, it'll set the validation values to be, like more or less like standardized correct values. And we have another function here we haven't seen yet. Expect that column schemas match. So what we're saying here is that these columns exist and they're of these types and they're in this order right here. So basically, this is a column schema. It's kind of a pain to like write out. So it's kind of nice that draft validation does this for you. Basically, if your columns change order, or if they change the names, or if their types change, this will detect that. Basically, it'll fail if it's not this. So it captures the schema of the table. So super neat. It's all guaranteed to work. It pops in a action levels value for you, like a little statement here. And it does the same sort of thing here. It passes in the table to this part. Okay. I know this is a lot. Any questions about this at all?
Rich, I think there's one question is about the scan data. Can you customize information shown in the details?
Okay. In the details. Which details? Sort of. I mean, not really. You can't really do too much here. You can, like I said, you can only change like a few aspects of this because this is more or less like just like a template, and it gives you what it gives. But you can change the order of things and like get rid of at least the top bar. And oh, I see what you mean. Maybe these details. No, currently you cannot. But I would love to have it so like you can like programmatically like insert different like statements for a certain type, like a custom type that you might have, and just give you like the machinery to like, or like the way in to like, set different like tabs and to do that. Currently it's not available, but that could be opened up as a custom thing later on. I never got that request before. I would suggest, although I thought of it, but put it in the issue in the repo, and I will definitely pencil that in for like future work, because that's a good one. It's a kind of an obvious one actually.
It's a kind of interesting question too. What would be, you consider as a competing package for the analysis that's being performed here?
Sorry, what was the question again? I didn't get the question.
Okay.
Sorry.
What are the competing package for this type of amazing analysis?
Oh, do you mean like this type of scan?
Yeah.
Yeah,
I
of
guess
course.
so.
Yeah,
I guess so.
yeah, it's quite a few. Like Skimmer is one big one. I believe there's summary, table summary. I counted is also it's hard to come up with names when it comes right down to it. There's at least a half dozen to maybe a dozen of them. I bet you the most popular one at the moment is Skimmer, and I don't know what it is. I think one's called HTML. I don't know. There's a few of them.
Yeah,
Yeah,
there are two
there's
common. One is Narnia and one is Viz Data.
yes, Narnia is one. Yeah, it does a lot of this, but I think it's getting into the other stuff too. Although I don't seem to have the missing data report here, but that's also quite similar. It does a much better job with that because it has many more. It specializes in that.
Yeah.
Basically, what I'm trying to do is make this general, but sort of like have like a lot of breadth, really, as it were. And yeah, there's a quite few of it, but I think Skimmer is probably the one of like that's the most popular of these types.
I think one last just pop out. What's the suggested data size limit for a scan?
It's a good question. What's the upper limit? I think what makes it slow would be like more columns, because with each column, it's creating one of these sections, and it's actually creating like lots of plots. Well, not really here, but at least like strings, at least it creates plots. I would say like maybe I tested on some databases as well, and sometimes it depends on the connection and like the amount of RAM available and things like that. It can get pretty slow even on small databases, mostly based on like the like how it's provisioned. I would say like maybe for a data frame, you're probably good with a few million rows, and with a database table, it's kind of like depends on your connection. I mean, we're not using anything too complex, just lots of selects and just lots of them essentially. So yeah, that's pretty much it. Yeah, I wouldn't go too high.
Great, thanks. That's all the question I found now.
Okay, great, thanks. Okay, so I'll continue on. First, I'll summarize. There's not much to summarize in this little section, but I'll do it anyways. So I said here, it's a great idea to examine data you're unfamiliar with scan data. And even better idea is using draft validation, because we can skip a lot of like frustration, especially initially, and maybe always use draft validation just to get those tables, within the validation framework right away without having to like, research every single thing. I mean, like I said before, it's a great jumping off point. You can always tweak things. It's guaranteed to work initially because it's just based on the data. And you may discover lots of things you probably won't think of. And it's pretty comprehensive. It checks columns for existence, through a schema. It checks for types. It checks for duplications of rows. And if there are duplicates, it won't add that step. But it tries to populate pretty large, populate the validation phase with a lot of steps, which is good. So yeah, I recommend these. There's lots of like little customizations you can do. I think it's a great way to start off. Probably should have led with that, but I wanted to sort of like, start with some theory first, I suppose. Okay, so I'm gonna close this up. I see some stuff in the chat, but maybe nothing. Oh yeah, okay, there we go. Not too much in terms of questions, so I'll move on to the third module here. We're making great time here, which is kind of good. So a little bit worried about that. Okay, so functions. This package has lots. We actually have like another set of functions which mirror exactly all those validation functions you've seen, except they include expect at the beginning or test at the beginning. So indeed, if we look at one of these, like, well, not this, but if you look at any one of these function documents, I kind of lied before because like each one of these like help articles does include quite a few functions, but they're of the same type. So it's call vals between, which is the validation function. Use that with an agent or directly on the data. Okay. And again, okay, there's more. There's also expect call vals between. And there's test call vals between. They're all at least with the same, ending. They're all the same type. They're just the way they're implemented is a bit different. The way you get out of it is different. So I imagine everybody here's heard of test that. It's basically, a testing framework for our packages. You test functions. This is kind of like that. It fits within that framework. The expect functions, they are expectation functions that could work inside unit tests. So I'll show you that in a second. These test functions, they're a bit different. All they do is give you true or false afterwards. Okay, so you can use them individually. They're great for programming. Say you want to have conditionals. You can use one or a bunch of these in your conditional statement, and you should expect, logicals to be the return value of each of these. Okay, so that's the differentiation. That's why you have these different, basically cousins of this function right here. Okay, so each one of these has an associate expect and test. So there's 36, 36, 36 of all these functions that are in the validation part of the package. Okay, so let's try using this. So let's use expectation functions. As I said, test that has a collection of functions that begin with expect. We copy that essentially. Well, we fit within that framework. It's not really copying, I guess. So we can put the files in a test file inside tests. That's usually how it works. Tests/test that. Okay. But also we can run them independently of being inside that test framework. We can just demonstrate it. Okay, so I'll show you small table C. It contains these values right here. Okay, so we're going to test that column. So our expectation with this column of small table is that values can be between 0 and 10, and any values are permitted. We have a few NA values. If we don't explicitly permit that, then we'll have failures, like failing test units. So there's a new argument here, NA pass. This is also available in the standard test function, NA pass. So if you set that to true, that means NAs are passing automatically. We're accepting those. Okay, I didn't put the argument names here, but this is left and right, so the bounds. Okay, so let's actually run this. We get nothing. That's expected. When this works, expect functions, you get nothing. Basically, nothing is returned. Totally fine. Within a test that framework, it knows that it passed if nothing's returned. Okay, this one's going to error. I know that ahead of time. That's how I would label this chunk. That's how this whole thing runs. So between 0 and 7 this time, NA pass equals true, just like before, but we reduce the range and we know we have an 8 in there and some 9s. So it's not going to work. So what you get is this. It's the same message as before that you've seen before with, just call vals between, but just something a little bit different inside of test that. So that's a little behind the scenes stuff. But basically, this is how you can sort of check that this works in general. Okay. So as I said, there's 36 expect functions. It's a lot. So it's overwhelming. We can do a kind of a cool thing. We learned how to use draft validation before to create a validation plan. It's kind of nice. There's also another function, which is kind of similar in a way. It's called write test that file. What it does is it'll create a test.r file using the agent from the draft validation file. I sort of combined two different things here. So let me show you how that works. I created the files ahead of time so you can see that. So if you run this, you get the file game revenue validation because I set that filing. So basically this is another data set in point blank game revenue. It's kind of a bigger one. It's got 2,000 rows, not that big, but it's bigger than small data, that's for sure. So we've got this. We made that file, game revenue validation. Let's take a look at that. Sorry, one sec. Okay, here we are. Great. So this is using draft validation. It does its thing. It creates this giant thing here. So what I've added at the bottom, I know this runs perfectly, and it creates an agent right here. It sort of assigns it. I've added another line, write test that file. And I've given, the agent to that. I'm calling this file that this is going to create game revenue. I'm just going to put it in the, in the working directory. By default, the path is going to be the test that path if it finds it. So it does some stuff to try to find where it should go. But just like this, we're putting it in the working directory. So if we run this, I have the file game revenue. So it's called test game revenue because it knows how to name it to fit within the test that framework. They all begin with test hyphen. So I'm going to open up that file. Okay, great. So it says at the top, generated by point blank. It libraries in point blank. It creates that table because you kind of need that for all the tests. So it does that in a separate statement at the top. And then individual like tests, like steps, like are encased in their own test that function call. So we see now expect call is character. Before it was just call is character and then all these values. Now we have expect. So it's kind of cool. And what it does also is these functions that begin with expect and test, they have their own special threshold function. It's kind of like a simplified version of actions because we don't really need the full thing there. We just need to have some sort of like way to say like this works or this passes or it doesn't pass based on a single threshold. So we have that there. We have either this or we can do some decimal value. But by default, it always chooses 1. Okay, this can totally be changed because you're just getting a file out of this. But it's kind of cool. So now it's basically this, but in this form. And so if you were to say, for instance, create an R package and you had some data you had to integrate as part of it, you can run tests on that data. Say the data has to change quite a bit. You're always, you're changing the data once in a while. This is nice to have. You just run this again and see if the data fits those expectations. And maybe you change these things if the data evolves to something else, but at least you have something, to know that this important data that you're using does fit expectations and it can be used within this framework. So kind of cool, You can do this. Okay, so I'm gonna go back. I'm gonna close these down. Great, and those are, again, they're in the repo, they're in the cloud project. Those will always be there for reference, those files. Okay, so, oh, I could have run that. Maybe I will run that right now, just so I can see it, because we don't often see that. Okay, so it's going to be test game revenue. The button is here, so you can actually run it outside of like the framework. I'm just going to run it. Okay, testing file using test that. It all passes done. Okay, so if this file were part of like a larger number of tests that was just in that directory, it would be this just one row, but we're just doing an individual file. So pretty cool. It works. Okay, great. So that's all the expect functions and write test that file. Any questions? I don't think there are any in the chat.
1.1 before we go too far. I think there's a question about in part 2. I'm not sure which part 2, but you mentioned that column names can have a label. How does this done?
Yes. Okay, great. Perfect. I'm not sure how it's done. I think it's through the labeling package, if I remember correctly. It allows you to have, oops, sorry, I'm trying to see how I can do this. Console, perfect. If you look at this, it's not obvious at all to me where it is. I think if you use attributes, they appear. And this is one of those things that I never get right. I'm pretty sure I have it wrong. Oh, yeah, here we go. Names? No, that's not it. Maybe you have to go to individual column. I mean, I know they're in there. How they get in there is a different story, and I'm never quite sure how to access them. Maybe you have to do a column name. Oh, good. There you go. You have to go to individual column names, and that's where the attribute lives. So label study identifier. You can do that yourself if you know how to set attributes. I think it's just attr and then set it. Or you can use a package, I believe it's called labeling or labeled. Labeled is the one, I think. Yeah, this will be the one. Wish it would give me a description, but that's not to be. But yeah, if you use labeled, I think it's easier to set those labels. Otherwise, you can definitely, what point blank does is it looks for like the label attribute in each of the columns. That's how it just looks. If it's not there, it's not going to show anything. But if it is there, pretty rare case, it does show it. But this is the key to it right there.
Thank you. I think that's all.
Yeah, thanks. Okay, great. Okay, so we're back to point blank test functions, another variant of these validation functions. So yeah, collection of test functions, 36 of them again. They're used to give us a single true or false. Okay, that's kind of nice to know. So say we want a script to error if there are any values in the datetime column of a small table data set. So we can write something like this. So if I run this, will it error? No, it didn't. Okay, because it's not true. Okay, but and we wrote a little message, if that were true, the negative case. It's a little crazy. But essentially you always want to have like negative in front and then like the stop condition inside. Okay. But in this case, this one does have an error. Okay. So in this case, we're using test call vals increasing, or the expectation that the call vals are greater than 1 in column A. Either one of these, you don't really know going in. You just know that one of these is going to be true. It will enter this state right here. So I'm going to run it. Yeah, fair problems to small table. I mean, which one is it? I don't really know. So let's see if it's this one. Is this true? That's false. So it's got to be this one here. I'm going to take this, run it. There's your true. Okay. So the cool thing about this is, you can change your statement to be, pretty complex. You can change the operators that are used. You can basically program with these because you're just expected to get a true or false, and you can do what you want with it. So it's pretty nice when you're programming. Sometimes you'll need it, sometimes you won't. We saw with the email case that could be useful, but we weren't really, we're using it sort of differently. But at any rate, this could be useful at certain points. So just to sum up, we can validate tabular data and test that workflow with the expect functions. I did mention that cool function right here, right? Test that file. Makes it really easy to take an agent and make it test that file for you from that. Basically, you iterate through making an agent, running the validation. Looks good. We just capture that in a file and then put it in the right place for testing. The test underscore functions, that collection is useful for developing conditional logic in programming contexts. I mean, there's probably better other workflows or use cases, but this is the obvious one for me. All right, we are at maybe halfway through the workshop and we're at module 3. I think we could take another break. Breaks are good. I'm going to say we have 3 more modules. This is actually like perfect timing, as it were. And I know these ones are a little bit smaller and a bit more relaxing than like the first 2, which are maybe a bit heavy. Again, any questions about the first parts or in general, things were confusing? Now's a great time. Take a break first. We can have questions after the break. But how about we take a 6-minute break? So we're at 15 minutes before the hour.
Sure.
And we'll begin again.
I would try to catch all the questions from Slido or the Zoom. Thank you.
Thanks. Yeah, because I'm not paying attention to those, but thank you. Appreciate that. Okay, we are probably back now. I'm trying to think. Sorry, can I trouble somebody with Slido updates? I really should have gotten that Slido. That's totally my fault for being.
Yep, just one more question from Slido.
Okay.
With scan data, can you define and use your grouping variable, like report the analysis by gender?
No, unfortunately, you can't do that at all. It just takes columns holistically and you can't split them. Strangely, though, not strangely, but incidentally, you can split by, categories or labels inside a standard point blank validation. It's an argument we didn't see, but it's called segments. You just segment your data, just like a special sort of like way of doing that, way you define it, but it basically splits between that. But fortunately for scan data, it doesn't have that.
One more, does a point blank play well with RC2 Connect deployments, like a living point blank report?
It does. Katie Masiello in RStudio has been doing a lot on that front, creating demos. I believe if you go to the repo point blank demo, I will just try to find that in GitHub. It has some examples of deployments, and they're successful deployments as well. They generate daily reports. Let me just see if I can find that. Point blank demo. Why cannot I find it? Okay, here we go. Hopefully this gets at it. Here we go. Here we go. Yeah, so we have a few examples here inside these folders. Oh, yeah, we can even see the results too, which is kind of cool. So I'm going to paste this into the chat. Great. Okay, so for connect deployments. Great. Yeah, and it's really nice to see this because like it runs like it's like a pretty easy way to get like daily and so like data quality runs going without too much setup, which is great.
Great, thank you. That's all the question.
Okay, awesome. Okay, so we're on to module 4 now. And okay, so this has to do with getting back to data validation once again. But we're sort of going to level up a bit. So say you're really good at this stuff and you really like the package, you're really on top of data quality in your organization, and you want to get serious. So basically the package, it allows you to do really simple things like just do simple checks, but also it allows you to scale up and do more complex things like you can check a lot of tables, you can do like really comprehensive checks, almost like the sky's the limit. You really want to be on top of things. So that's what this module will show you. Some ways where you can really have an auditing trail for your data quality and better reporting for like multiple runs. So let me show you a few things you can do. So writing agents to disk. So say you want to save results. You want to know maybe a month from now how things went a month back in terms of your standard data quality checks. You can use the xWrite disk function. So basically, it's kind of like save RDS or write RDS, but it's a little bit special in a way. So let's say you write a point blank agent to disk. This is useful if you want to continually save the interrogation results as part of a large data quality process. Here's an example. Agent is saved to disk with the date as part of the file name. So I provide some stuff there, some affordances for making it nice to store. So I'm going to run this in the console. I don't want to flood the output here, so I'm just going to run this here. Great. I mean, we got the agent, we might as well look at it. So here we go. Great. So there's our report. Some stuff failed. One thing failed, most things passed. Whatever, it's a report, and it's got a timestamp and the beginning and ending timestamp for like the entire thing. So great, so we have that. But we want to keep this because we may need to look at this later on. It's always good to have information at hand. So xWrite disk, we take the agent, we give it a file name, and we give it a path. So a fixed date, let's just get into this first. So this is provided by point blank, and it just allows you to do nice things like add a date to the file name. Great. If that's you're running runs more commonly, like you want more granular, you use date time. There we go. So I think it uses UTC time. You can change it to like your local time. I think UTC time is probably like better. You can change the position. You can do all sorts of things with this, like beginning, start. Let's do this. Yeah, so it's pretty flexible. You can do all sorts of cool things to adorn your file name. So when you save things, it's all organized. When you get back to it, you can just see like a directory full of these. It makes some sense. They can be ordered any way you want. So that's what these functions do. So yeah, we're saving it to small table tests. We're gonna write that to disk. I'm not gonna do it again because I don't want to like mess up the directory that I have, but it went into here. Okay, so I did one of these. This is just one. I did a bunch of other ones too, because the point is going to show you what you can do with a number of these things that are saved. But okay, we'll get to that. Okay, but one next step is you've got something written to disk. You may want to read it back. Okay, so we can do that. We can just assign it to some sort of name. We're just getting our historical record of like agents saved to disk. We supply a path, file name. You can supply a path in here and just ignore this. That's a nice little thing to have. Okay, let's just run this. Great. Okay, so it gives you a little feedback, saying something was done. Agent has been read from this. Good. So let's see if it's actually there. Great. Yeah, so it came back, which is good. So you can read back past things. This is not too outrageous. If you save an RDS, it's kind of like this, but this kind of does some stuff for you, like the writing to disk. It does a few things that I'm not really going to get into. Extracts are gone because, okay, I will get into it. So you can choose whether it's to save extracts from X-write disk. The default is no, but you can say yes, let's save all the extracts. So that's an option. In this case, reading it back, we get all the information back. We don't have the extracts, but everything else is back as it was. And we can use that to, get data from it. We can use, I'm not going to run it, but you can use get Agent Xlist and then get all the data from it programmatically. Okay, so we were able to save to disk an agent, read the agent back. Great. Okay, so now we're going to get into a new type of object. It's called the multi-agent. So why would you make something like this? What is this thing? So a common task might be to see how data quality is changing over time. If you have multiple saved agents that check the same table, that's one scenario. You can have like agents checking multiple tables, different scenario. But say we have this one. We can make a combined validation report that shows all the validations. Okay, so as you see in the directory here, we do actually have 5 saved agents. They just change by day. So with that helpful, function a fixed date, I was able to make that pretty easily. So we can create a multi-agent like this. It's not the most convenient thing, the way I have it. I'm sure it could be written better than this in lots of ways. But I have it like this just for, it's not too scalable, but we have it here just for demonstrating how it works. So basically what create agent takes is like a collection of agents to make one big agent. It's kind of like a unified agent. I call it the multi-agent, and we'll make that object right now. Do the console. Okay, that's from the inside, but basically we made this multi-agent. Okay, so we can get a combined data validation report from it by default. And basically when you print the object itself, it just gives you defaults, which can be customized. But by default, all validation reports are stacked together in the long display mode. Okay, let's show you what that is. I'm going to show you the multi-agent, the long display mode. Here we go. Okay, so I'm going to expand this a little bit. We can change the title of all this stuff too, but that's part of the customizing part. So this is one check. This is, we don't have a good label for this that distinguishes it, but this is basically the first one. This one's the second one, different. The third one, fourth one, fifth, and that's basically it. This is why having a good label is nice. You can maybe put the date in that you made the check. At any rate, this is basically the order that you put them in. Okay, great. So that's good. The order you put them in determines the order you get the reporting in. Good. Okay, so that's nice. But you can customize this, and you can change the title. We can change the display mode. That's kind of what we want to see now. We operated on the same data set, small table, but we kind of want to see like a sort of condensed report, something that scales to like lots and lots of runs. How the data quality changes over time. So we can use display mode wide. So I'm going to run this in the console, and it takes the multi-agent. Get multi-agent report, kind of matches. Okay, just going to run that. And we get this. Okay, so we have our title there, which is great. Uses Markdown in case you need it. Uses the one table, small table. That's what we labeled it as. And it's kind of cool. This time it arranges it by time. I mean, it was already given as like, this order, but I think it will rearrange it in terms of time, because that's the key thing. You want to see that, as time progresses, how your runs change. It's totally a different type of report, though. You get a very condensed, summarized view. You're not going to get like a giant table, like slimmed down to like, like this width. You're going to get like just some aspects of it. You'll get the run, like the step index. You'll get the pass and fail for this step. And this step may change. Like I changed it so like, calls, vals, regex was not used in the second report. So it's just blank. And then later on, it's used again, but it's deactivated. That's another thing you can do. You can sort of like pause steps or temporarily deactivate them. So that's what we see here. Yeah, and this thing here, we have to learn what this is. This is the hash ID. So this basically distinguishes the different steps. I mean, the basis of them is like the same function, but the values are the same across here. So like they're the same step. They're the same type of validation. So that's how this works. If you had lots and lots of these, it would scroll to the right. So you can have, dozens of these. If you had just a few of these, it becomes a bit wide. It fills in more of the space. So there's a few different like widths of this thing that you can see. And you see, so it rearranges nicely. So it's pretty flexible because it's pretty conceivable that you would change some of these and deactivate them as time goes on. You may add more, so you just see more at the bottom. But that's how this works. Okay, this is a really short module, but I think it was important. If you had something where you wanted to scale up, you'd want to save your reports somewhere, and then you want to read them back and get a different type of report. So that's basically it. You can save agent to disk, read them back. It's all about record keeping and data preservation. And multiple agents can be combined together. You can make specialized reports, either a long table stacked or the evolution of data quality in a single table wide display. Okay. And that is basically it for this short module, which is module 4. Is there any questions or comments? It could be anything, any type of.
Not from Slido yet.
No, okay. I see nothing in the chat, so I'm all clear to go. Go ahead.
Yep.
Okay. So the last 2 modules in this workshop, they focus on data documentation. So we're actually kind of done the data validation part. If you got any questions, I'm definitely going to, answer them later because they may just materialize later. And even after the workshop. So this is a good reminder that questions, I take them either in GitHub issues, in the discussion section, pretty much everywhere you can reach me. Those are the best places though. Okay, but yeah, let's move on to the next section here, which is module 5, introduction to data documentation. Okay, does anybody have I can't just ask this question, but maybe I could. Is it data documentation done? Is it a common practice? I think it's half done. And it's called different things. Sometimes it's just making a data dictionary. Sometimes it's just describing your data. It means different things. And unfortunately, a data dictionary means a different thing in a database context sometimes. But at any rate, this is all centered around describing your tables and communicating what the tables are, like what variables are in there, what do they mean, why they're significant, like the table as a whole, like where do we get this from? Is it important? What do we use it for? Who makes this table? So it's really just writing, and it's like technical writing about your table in a way. And so point blank has a lot of functionality around that whole thing. Okay, so I state that it's a good thing to document your data sets. It's good for you, it's good for others. It takes time. I'm hoping point blank makes it simpler, makes it better, so it's worth the time. So we have several functions that let us define portions of information about a table. Okay, more on that in a bit. It's a little bit nebulous. And we have something called info text, basically just writing. It's just text, really. It's informational text that pertain to individual columns, the table as a whole, and whatever additional information makes sense. Okay, so examples, because this is just like nothing until you see an example. So small table, let's refresh our memories on what that is. I'm just going to clear this. Okay, so just our example table. I know it's not much to, you have to imagine a big table, but this is actually really good for instructional settings because it's something we can manage on one screen. Okay, so it's a different set of functions. It kind of like is similar to the validation workflow. You start with a create function. In this case, it's create informant. Sorry, it's a long function name, but that's what I chose. And then it ends with another function that sort of wraps things up. Basically, it queries the table if you need it. And we'll show you when that's used. But basically, you should use the similar construction. And I'll demonstrate that. Okay, so let's just do it. Let's create the informant. You pass in a table. Just like with create agent, you can give it a friendly table name. If you don't include it, it just includes a table name, but you can make it a little bit different. Maybe you might want to just Lutz underscore or something like that. Maybe you want to change it in some way, but it's nice to include. Label. You can include a label. That's just part of your report. And here the report is super important. It's kind of like the main thing. There's no real data underlying it. I mean, there is, but you really just want to see the report and publish the report. That's kind of like the key thing. Okay, so let's create that informant. Great, I did it. Okay, now let's print it. This could be customized, but just printing it gives you the defaults. Okay, let's scroll this up and see the report. So it gives you a title, which you can totally change. Label, you set that yourself. It gives you information about the table. It's a little bit different. It gives you the number of rows, number of columns, kind of like just for free. And it gives you this one section called columns. And it's mostly empty. There's not much in there. There's nothing in there actually, except for like the name of the column and the type of the column. Sometimes it can be 2 types in the case here. But we get this. And it's really fast to make, obviously, because it's just text. But there's nothing here. We have to add text. So we can do that with a number of functions. There's actually 3 main ones. Info tabular. So that's adding information or text pertaining to the data table as a whole, creates a section. Info columns, add info for each table column. So we get that right here. We already have that filled in, but we don't have any writing on it. And info section, this is just adding arbitrary sections at the end. And you can provide any additional information. You make sections and subsections. You just really sort of fill this out if it's important. And yeah, so that's what these 3 functions do. Okay. So let's try adding some information with each of these functions and then look at it. So we can iterate pretty quickly on this. So create informant, we got that. Now info tabular. I'm gonna do a cool thing here. I'm just gonna take this and paste this right in the console, and we'll see step by step what each thing does. Okay, so in this case, info tabular, we're creating a section. This is our own name, description. This table is included in the point blank package. Okay, so let's see what that does. Great, look at that. So it just says, it makes a section called table, and then your subsection is called description, and then your text is included, and it's all markdownified right there. Great, good first start. Okay, now these columns, let's actually describe some of these. Not all of them, but we'll describe at least one. So datetime, we make a section called info. This column is full of timestamps. Okay, better than what we have here. So let's actually take this, run that. There we go, info. This column is full of timestamps. We can change this to whatever. We can make this like emoji. We can make covered in backticks and put a space, make it longer. So we can, that's the name of the subsection we're making inside here. Okay, so info section. So here we're making a subsection. It's called section. Actually, no. The way info section works is you define the subsection name, further information, and then you provide its own little sections inside. Okay. Sounds a little crazy, but let's just run it. This appears at the bottom, so we have to scroll down. Let's see here, further information is the section name, examples and documentation, and then the text for that. So again, because this is Markdown, we can do things like add links, and they actually work, and these are styled nicely for you. That's what this does for you. And it generally looks pretty good. And as you can imagine, we can keep going, describe all the columns, like add a lot of further information. We can really pad this out, and we'll show more complete examples, but I just want to show the basics here. So key things, create informant, info functions like info columns, info tabular, info section. A must is having info columns. Otherwise you just have, empty descriptions of the columns. So that's kind of good. So we got that. Now let's go into each of these little things here. The table section and info tabular. So we did that before. We used info tabular description. It just sits inside here. This table is included in the point blank package. Okay, we did that. That was used to make the description subsection. All section titles are automatically capitalized. We can define as many subsections to the table section as we need. Oops. Either in the same info tabular call or across multiple calls. Okay, that's a lot. So let's actually run this. Let me just run this whole thing so we make sure we have that object. Great. And so now what we're doing here is we're using info tabular again and making a section called updates. This table is not regularly updated. So that fits within the table section right here. It's just going to go underneath the description. All right, good. So this is nice. So now we have a bit more information. We have subsections. Life is good. Okay, so the table section is a great place to put all the information about the table that needs to be front and center. So here's some examples just to get your imagination going. What about a high-level summary of the table, stating its purpose and importance? What each row of the table represents. That's a good one. The main users of the table within an organization. A description of how the table is generated. And information on the frequency of updates. That's a good thing to put front and center. If you don't really need it up here, you can put it at the bottom in further information or whatever you want to call this other sections. Okay, so that's cool. Now we're going to move to columns again. I mean, we showed you how to fill in information for the first time, but there's a bit more to this function than that. There's a little bit of detail. Let me show you with an example. Okay, so individual columns will serve as subsections, as we see here. Each one uses a subsection. And the interesting thing, that's why I noted here in the text, is that the information is additive. We can make multiple calls of info columns and disperse common pieces of info text to multiple columns. So say you had something that was common to each of the columns you want to include at the end. You can just state multiple columns get this bit of text glommed onto the end of the existing text. We'll show that. There's some use cases for that. Okay, so let's do that right here. Informant PP, that's Palmer Penguins. We're going to create the informant. We'll go one step at a time and see how this works. That's the best way to sort of like understand. Okay, so here we go. We got these columns right here, quite a few. We got the rows and the columns, the counts right here. Great, that's our start. So info columns, we're targeting species, which is right here. Now the info we're going to include is a factor denoting penguin species, and we're using a little bit of Markdown to show this in italics. Okay, so I'm going to run that. Great, looks great. So we're going to move to island, same sort of thing, adding a little bit of info. It's right here. Wonderful. Bill length, millimeters, bill depth, flipper length. Okay, so we're saying many of the same things. Okay, great. Got those, wonderful. Okay, what about this? We got something that's totally different here. Ends with MM. Okay, so that would be this one, and this one. And we're putting info in parentheses in units of millimeters. Okay, so this is the thing I was talking about. You can add bits of text to multiple columns in the order that you define these statements. So this is kind of nice because like we're sort of expecting something here in terms of like, details about units. So let's just try that. Okay, gotta scroll down a bit, but yeah, this all came in. You did 3 at a time, which is great. So bits of text, you might do that same thing with labels, for instance. You might make like a little label. There's affordances for that in this part of the package as well, too. Sort of like add a bunch of things to different subsections. Okay, so we're doing this again. Body mass G, we didn't do that yet. That's empty. I copy that down. Now if I scroll down, body mass G, it has its own text. Okay, we're gonna do the same thing for the last 2 right here, just like the very end. Great. Now we have all the different columns, like with some text. That's basically a data dictionary. Like that's like the very basics. And again, with all these things, you could like publish. You can export the report. You can put this in Connect. This is just the same as every little bit of reporting. You can export the HTML file, embed it somewhere. Lots of options. So I'm going to just save that to that object. We've already seen it, so I don't need to run that again. But this just explains that ends with is what we use here. Could be used when targeting columns. And we can use all these different tie select helper functions, like ends with, contains, matches, everything starts with, as we do in the other part of the package to do data validation as well. You can use these as well. Probably not advised with data validation because you're kind of like guessing at this point, being explicit, but it's pretty good here. It's pretty good because the stakes are a bit lower. Okay, so that is the beginnings. I see you have some questions in the chat, maybe. Great.
There are 3 actually. I think, may I start with probably the most recent one. Is there any way to pull values from the data via R for the info description?
Oh,
for example,
yes.
unique values in a column.
Yes, that's a must-have, and I do have affordances and things just for that. You're gonna love it because you don't have to like get manual with it. You're basically in the API, and they're called snippets. And basically, you're querying the data and you're generating the text like on the fly. The only thing you have to do is make sure that the data is reachable. So at the very end, you do like this incorporate function, which basically like runs all the snippets, gets the text, puts it in the right spot, and then like anytime the data changes, the text updates because it's basically generating text from the data, which is what you want. So we're trying to avoid things like being stale, and doing lots of manual work, but we'll see that. So right here, we did a thing which is very manual. We got different years. We can totally do that with our own thing with info snippet, but more on that soon. So that's basically that. That's that. So was there another question?
All right. Second one is industry standards should allow us to create standard agents. Are you aware of industry collaboration to build standard agents like CDX, EDC, or Atom?
No, not yet. That seems like an obvious one. I think it's because we don't have that yet because and we reached out because a lot of people don't know about this package. So it's a visibility thing. I think this package can definitely make standard rules for that, because I looked at some of the rules for CDISC and things like that, and they seem like things that could be covered pretty easily by point blank. So I don't know if anybody's interested in that sort of collaboration. I'm all ears.
Yeah,
it can definitely happen. Yeah,
I actually have a similar feeling. Is maybe the R for submission team will be interested in looking into this further.
Yeah, because I really feel like that all the things I looked at in terms of like the rules that can be covered, and if they can't be, I can definitely make it so.
Yeah. One more question, maybe I'm not sure. That maybe go to the previous module. It's when you show the multi-agent wide reporting. Can you explain a little bit more about the hashes?
Yeah, certainly. So say you have like call vals between, and you have, so you have the agent, that's fine. Columns, do bars B or something like that, or just B. And we have 2 values right here, 3 and 5. So this takes all the values and then it creates a unique hash based on those different values. So that way you can distinguish between another step, which might be something like this, and maybe focus on column C. We can't distinguish between different steps just by the basis function, which is call vals between. We have to make sure that everything that is different or can be different is grouped in the same sort of like hash. So the hashing is good. It basically takes all information. It basically makes groups for you, or it lets point blank know and lets the user know that, yeah, this is the same thing. Your arguments might be out of order and you may have the same data. So it basically just says like that's the exact same rule that's being used. So, say for instance, later on you change your test. So like, like this changed. That'll be a different hash. It'll be on a different row. And so like any, steps beforehand that have the same rule will be in subsequent runs, won't be filled in anymore, but the new one will survive on that second row. That's kind of how it works. It's basically so you keep track of things in an easy way. It could be displayed a little bit better, but at least it keeps things consistent.
Great, thank you. That's all the questions.
Yeah, thank you. Okay, perfect. So I'll go back into this. Okay, creating extra sections with info section. So This is kind of nice. This is the kind of like at the end, you just want to create arbitrary sections that describe things. Sometimes you need that, sometimes you don't. You might be sort of fine just putting at the top in table, but there's basically 2 places. Okay. So I say here, information doesn't fit into table and column sections, can be placed in extra sections with info section. These sections by design go at the bottom in the order of creation of these calls. So let's try that with the Palmer Penguins data. So I have this saved or assigned to that. We're going to modify that a bit and then reassign it to the same thing. So info section, we'll call it source. And I got a really large chunk of text. I basically just copied it from the package website. These are basically references. And it has things like links, well, mostly just links, which are different. But I have it here as a vector, and it seems to be just fine. So let's actually run this and see what is happening here. Oh, hang on. There's more than that too. I've also got a note, which is another section here. And well, we'll just see what happens. So I'm going to run this. Okay, and then paste this over here. Make this a little bit bigger. Okay, we got all the stuff we had before because we're just like adding onto it. But now we have in-source references. And now we have these nice links we can go to. Really great stuff. And we have a note at the bottom that is the same note that we put in there. So basically just copied and pasted. It's pretty good. It handles text pretty well. And it does like all the resolving. It does like little soft breaks here for you, like paragraphs. So paragraphs are with C. So all in all, it's pretty nice. It's good to have. And that's, basically additively, adding sections and bits of text. Okay. Oh, wow. I got some ideas here. It's like a little idea board, if you will. What other types of information go well in these separate sections? Here's some ideas. Any info related to the source of the data table, definitions, explanations of the terms used above, persons responsible for the data table, maybe contact info, further details on how the table is produced, any important issues with the table and notes on upcoming changes, because this is communication, right? Any important, links to other information artifacts that pertain to the table. It could be report generation metadata, which might include things like update history, person responsible, instructions on how to contribute, things like that. So I just thought I'd throw some ideas out there in terms of what you can include. I mean, you have all this infrastructure for like, having sessions, but sometimes, the ideas are important as well. Okay, as before, we have a way to customize the information report. We can do that with the get informant report. A lot of these get functions will have the name of the report, and then you have a bunch of options. So let's try this one here. We can change the size of the report. Say this is like too wide. And then like the title, this is not a great title, like for most people. It's pretty bad actually, but you can change that. In this case, we have a keyword. It's surrounded by colons, table name. You can just put it in text, of course, but this just puts the table name at the top. Pretty cool. So let's, I think I ran that. So I'm gonna copy that here and then show you the new report. Okay, yeah, it sort of went down a little bit in terms of size, not by much. You can really change this to whatever pixel size you want. But here it is, and the name is now Penguins. It's just the name of the table. And yeah, it's the same table. We just customize it a bit. And there's more customization options as well. I don't think there's too many. You can change the language. You can change the locale. That's pretty much it. There's less than there is in the Get Agent report, but they're there nonetheless. Okay, so if this report looks really good, publish it. That's the whole point. In a variety of ways. Connect, CordoPub. If you haven't heard of CordoPub, it's quite amazing. It's free. Give your username. You can like use the Cordo CLI for that. You can export to standalone HTML, we export report, many options. So I have it right here. Where are you? Where's the Penguins? Informant Penguins. There we go. It's just hiding in plain sight. So I can see that in web browser. Here we go. So basically here it is right there. Looks really good. So yeah, it can make that HTML document for you, and you can embed that in lots of different places. Great. So just to summarize, this whole first part of data documentation, it's not the end. There's more to come in the next module. but I thought I'd break it up into two because there's lots there. So you begin the process of documenting a data set with create informant. Use info tabular, just grab a table in general terms. That'll be the first section before the column descriptions. With info columns, you can document each column in a data set. When you create the informant, you get like a sort of like stubs of like all the different columns. You then fill in the information. Arbitrary sections of additional information, you can add those with info section. You can control the look and feel of the information report with get informant report. You can export it with export report. You can also do save. Oh, I forgot the name of it now. Anyways, as before, when you saved the different, it's X write disk, you can do that with the informant as well. That accepts a variety of different object types from point blank. So you can save them as well in different states. Probably less useful, but it's there. Okay, so that is it for that module. I'll look in the chat for questions. Okay. Multiple tables within a database. If Melody can just like explain that question maybe once more. Does this do multiple tables in a database? Trying to get the question. Maybe if you write in like what you mean, I'll get to that in a second, but I'll do Gavin's questions. Okay, is this scalable to document multiple tables in a database? No worries, no worries. Yeah, but not in one report though. I don't quite have the whole framework where you have like a data catalog yet, where you can just like, tab through a bunch of different tables. That is sort of like in the pipeline. It's sort of like a vision of mine to do that. But you can definitely do it in multiple scripts for the same sort of thing. And it does work with database tables as well. Like all this stuff does. It works with a wide variety. So good to know. If you have like MySQL, you got Postgres, works with BigQuery. There's a bunch more, DuckDB as well. This also works with Arrow data sets as well, but only the informant, like the data documentation part, not the validation part yet. Okay. That's also explained in case you want to reference in the actual, like pretty much each help file has that, like what types of tables can be passed in right here. So basically Spark data frames, all these different types, and works the same with informant, except for Arrow, or it's the opposite, I should say. Okay, can I create interactive informant reports in a Shiny app? For example, letting the user choose the language. Oh, no, not quite yet. Unless you're like a Shiny whiz and you want to generate, you have the controls. I think you can. You just have to, this is imagine this. I think you just have to use this and then set the language, like lang. Of course, all your text has to be in that language too to sort of match the labels that we generate. But I think it's possible with a little bit of work. I mean, all the stuff is there to make it possible. It'll just take some work to create that, that whole app. Okay, would be good to have a way to have one cover page. Yes, definitely would. That's the whole idea of like a data catalog, which I don't quite have yet. Sort of like a way to sort of like have one interface for having multiple reports, like per data frame. Seems like an obvious thing. It's a bit of work. No problem, of course. But the context you do that in, I think it's going to be like Shiny, but maybe not. Maybe you just want to have a simple HTML report, which is also possible that way too. So I think we need both. How would you combine reports and multiple tables and exporting HTML? You kind of wouldn't. I guess the framework you would use is Shiny for that, and then use basically that way to get raw HTML into that. So if you have like the exported HTML files, you can definitely take those in as inputs. Quarter book with a section for each report. That seems like a good one too. It seems like a lot of different like mediums for like disseminating all the different like reports and having them sectioned. Quarter book seems like an obvious one as well. Maybe not so much the book, but maybe, I'm not sure. But it could definitely be like something in Quarto. And it's good that so far, at least doesn't seem that difficult, because this does render, like these reports do render in those in Conjoint or Markdown. I wonder, did I miss anything? No, it seems like I covered all of that.
Slido is quiet.
Slido.
Everybody is doing Zoom.
Yeah.
We're good. We're good on Slido. Yeah.
Okay, great. Awesome. Okay, so that's like part one of data documentation. And the timing here is really great. I was worried that we weren't able to cover it all, or I'd finish an hour early, but that's not the case. So yay. Okay, so let's continue on to the next section. Actually, let's have a little bit of a break. It's always good to have a break. Let's do a short break, like 3-minute break, return, at the half-hour interval. And I think that's a good idea. So see you in 3. Okay, well, thanks for understanding that short break. It's always good to have a little bit of a break just to relax for a second or two. Okay, so let's get back into data documentation. We're going to get deeper into documenting data. I mean, what you can make just with the information in Module 5 is perfectly serviceable, really great stuff. What I want to show you in Module 6 will be like really amplifying and making an incredible data dictionary. I mean, the results will be amazing. Sorry for overstating it, but it's really good stuff here. So I'm really happy to get to this and have a bit of time to show it to you. So yeah, we now know how to make a useful data dictionary. It can be published and widely shared. That's totally the name of the game. We used a point-blank informant with a set of information functions to generate info text, throwing a lot of terminology at you, but hopefully it's not too much. So we put that text into the appropriate report sections. That's what we did. But now we're going to take this a number of steps further and look into some more functionality that makes this info text a bit more dynamic, and also include a finalizing step in this workflow that accounts for evolving data. Because sometimes data changes. It could be quite often, it could be once in a while. But when you have evolving data, it's really hard to keep up with it, because every time it changes, your reports may be more and more inaccurate. So, okay. So info snippet, that's the next big function I want to show you. It's like the last info function that I'm going to show you. But it's really cool. It allows you to create snippets of useful text. Okay. So a great source of the information about the table can be the table itself. Suppose you want to show some categorical values from a particular column, a range of values from an important numeric column, KPI values that can be calculated using data in the table. You can do that with info snippet. You give the snippet a name, you give it a function call, and then you have to sort of say where to insert it. You have to sort of provide a directive there. So two things. You provide the thing that gets you the information, and you instruct point blank where to put that bit of information. So let's do this for the small table data set available in the package. Again, if you haven't not sick of this table already, here it is again. It's a really small table, but it's good because we know what's in it. It's all here. So if you wanted to get the mean value of the data in column D, which is right here, rounded to 1 decimal place, we can do it with this expression right here. So we know how to do this. Great, that's the mean value. Be nice to put into the table, into the data dictionary, in case that's important. May not be the best example, but it's, we can see where it's coming from, where it's going. So inside of the info snippet call, which is used after creating the informant object, an expression would look like this. So we're taking this whole thing, replacing small table with a dot, and then just piping it through. You can use a function as well, but this is one way of doing it. So table, then we're getting column D, calculating the mean, rounding it to 1 decimal place. We're going to call the snippet mean D. We're just giving it a name. It's like an ID. Great. So we have that. So let's run this whole thing. Okay. Great. So if we run informant, we get this. Basically, nothing nothing to do with that because we didn't actually put it anywhere. So we just basically have like the table, the column stubs, and that's it. Great. I mean, we do have this now stored in the object, but we're not seeing it. So we got to change that. So this data set associated informant, it's represented with the leading dot. That's been fully explained. And this is kind of like a functional sequence, just saying table, we're carrying it through and getting the meat. Okay. And important, gotta use the tilde because we don't actually want to run this right away, like evaluate it. You want to sort of store it. And we always do that with the tilde, at least in point blank, that's what it does. Okay. So next, we need to have a place to put it. So the snippet has been given the name mean_d. So we know it will produce this value. We've seen it. It's right there. What can we do with that? So we got to put it in some sort of text and use the snippet name as the key. So it works just like glue does. If you ever use the package glue, it uses like these curly braces and then some stuff in the curly brace to, put stuff in. So same sort of principle applies here. We got, the mean value is in curly braces, mean D. We know that this has the snippet information. When you're processing this text, it just scans for like these names and it can put the actual evaluated result into the text. So let's actually run this. Okay, performance. All right, excellent. So, oh, yeah, we don't see it. There's a reason for that, and I'll get to it. We still have mean D in curly braces. Okay, obviously not what we want. So we got to do more than just that. There's one last step. We got to finalize everything with incorporate. So what this does is it instructs point blank to query the data. This is similar to using interrogate when doing the data validation. So it's like the final step. It's kind of like you surround all your directives with the beginning and the last step. Yeah, and the reason why we have to do that is because we don't actually touch the data until we ask, we ask the data to be touched. Because it may exist in a database somewhere, we don't want to, always query it. Sometimes it can be slow. There's just good reasons. So we have to include this. So let's run it again. This time we're doing the whole thing, so you can see all one sort of like one fell swoop. And then, cool. Okay, this is interesting. When you run incorporate, you get some information back in the console. Information gathered, snippets processed, information built. Okay, it's very promising. Let's take a look at this built information. Excellent. Look at this. The mean value is this, which is far greater. Wonderful. If your data changes, this will change. It's great because you just include something programmatic that gets a value out. You put an info snippet, you gave it a name, you use that name to put that value somewhere in some text. It could be anywhere. Okay, good. Okay, so you can provide any function you want, but we actually include a bunch of like useful functions in the package. Makes it easier for common things. They all begin with the snip prefix, and they are, here we go, snip list, get a list of column categories. It's kind of cool. Snip lowest, get the lowest value from a column. Snip highest, get the highest value from a column. Can make a range. Snip stats, get an inline statistical summary. Pretty cool stuff. Let's use some of these. So yeah, they're used as the function value in info snippet. They have arguments, and some of them have lots of arguments. Like snippet list has quite a few things, so you can really craft that list in a way that you really want it. Okay, so I'll show you some of that. So snippet list, that comes first. So when describing some aspect of the target table, we may want to extract some values from the column and include them in a piece of info text. Okay, it's pretty efficient with snippet list. So right here, we're using Palmer penguins again. And we're making 2 snippets. This could be in any order. The snippets could come last, they can come first. That doesn't seem to matter. Okay, so we're going to call this species snippet. We're snipping a list from the column species. So let's actually take a look at this and we can sort of like envision what this will do. So just looking at the top. Species, okay. So basically it's got a factor, but basically it's going to take the text and just like condense it down into like 3 unique values and make that list. And it'll present it in ways based on the options in here. There's a bunch of options. There's like limit, sorting, reverse, the separator, and or Oxford, as code, quote string. So many things, lang as well. There's lots of options to make sure that the list will give you options for making the list the way you want it to be made. Okay, we're doing it for island as well. There's how many islands? I totally forgot. 2, I think. I forgot. We're going to find out. So we're going to make a list based on the island column. Great. Okay, and we'll see here, we got to put these things somewhere. So species snippet, you can see just by like double clicking it, it's going into here. Okay, a factor denoting penguin species, in parentheses, species snippet. Great. Same thing with island snippet right there. A factor denoting island, island in Palmer Archipelago, Antarctica, island snippet. Okay, so let's run this, the whole thing. Great, it did the thing here where it notifies you that things were done. Gonna run this. Great, look at this. It made these lists. I didn't have to like, like fetch them, like do weird things. I mean, you could, but this is kind of nice, especially for really more complicated things. And if you have a giant list, it'll like limit items for you. It'll do things like that. And so it does scale nicely. It doesn't give you like a massive list. There's a cutoff. Great, okay. So this works for numeric values too. Let's use snip list and provide a text snippet based on the values in the year. Okay, so we're going to carry on with this. Just add to the informant underscore pp and incorporate again. Okay, now if you run it once more, it's basically a revision of the previous one. Let's go to the, oh, here we go. Yeah, set a year, 2007, 2008, and 2009. Great. And you can tweak the way this list appears. You can change all sorts of things about it. Great. Okay, so we have two more here. Well, actually, not 2 more, but this is another 2. They go well together, snip lowest, snip highest. I'm pretty sure you can imagine where this is going. We're doing pretty much the same sort of thing. I'm just going to quickly run through this. Info columns, I'm just noting here that we're actually including the snippets here, but we're not defining them until later. That's totally fine. You can put them wherever you want. It doesn't matter what the order is, at least when it's regarding snippets and like the, the other things like the columns. These can go anywhere. Okay, so basically I'm snipping lowest, choosing a column, snipping highest, max depth is what I'm calling it. I'm just giving my own name. Looks great. In this case, I'm just doing the largest flipper length. That's what I called it. Snip highest, flipper length, mm. Okay, so let's run this. This again is adding to what was there before. Great. And what I'll do is I'll copy that into the console as I've been doing, and we'll see the updated result. So here we go. Pretty nice. A number denoting bill depth in the range of 13.1 to 21.5 millimeters. Great. Largest observation is that because we snipped the largest value. Okay. Again, data changes, this changes, maybe. Okay. So we can see from the report, we can creatively use the lowest and highest values obtained by those functions, those snip functions, to specify a range or just show some maximum value, whatever. The ordering, again, not important, at least for info snippet, as that's, as that's arranged, it doesn't matter. I mean, it's kind of good if you put it like in as a block together, just for your own sort of like code maintenance, but it doesn't matter in the context of it working. Okay.
Rich,
yeah.
I think there's one question from Zoom. Can you check if columns change from one agent to another regarding the multi-agent objects?
Yeah, you can have a step, which is basically call schema or call schema match, I believe it is. And that checks like all the columns in the arrangement, and you have a step there. And if, the multi-agent is essentially is multiple agents. So if that changes in one step, you'll see a failure pop up over time in that wide report, or even in a stack report, you should see like things will fail at one particular time. So that's like a sort of like a broad sort of all-encompassing way to check like your table structure is, like being maintained through time. So I'd say yes to that.
2 questions from Slido.
Okay.
sometimes with inline code, I personally have problems to do cache. What's your experience with this?
To do what, sorry?
Yeah, cache, caching, or I mean,
Oh yeah, of course. Yeah, that's right. Yeah, I don't really know what's the question there. If the person has problems, but
let me recopy it over to the Zoom to make it.
yeah, sorry, thank you.
sorry,
Sometimes you just gotta see the whole question. I don't know why.
Yep, understood that.
Yeah. Oh, what's your experience with this? Okay, great. Yeah, sorry. Yeah, I mean, we don't normally do caching stuff in point blank. And so basically, I think this could be mostly avoided, I think, is my thing. So that's my experience, at least with point blank. Basically, you're always like, using like the fresh object. It's not really cached. You're always like looking at the object as it is. Okay. So hopefully that is okay. My experience is like, basically, I don't really have this experience.
Right. One more question is, the data frame have 1 million rows, but only 8 unique values in a column. Will this info snippet work?
Yes, it should scale pretty well because the queries to get this are pretty simple. Basically, use dplyr under the hood, and that's being translated to pretty efficient queries. We're basically just doing like a group by and then like getting the values. I'm not sure what the actual thing is, but it's pretty fast. I mean, if we do this on a giant table, it probably won't take much more than like 1 or 2 seconds. It's been my thing. I got some proof of that like online somewhere. I don't have it here, but I did sort of like do a torture test on this sort of thing, see how long things would take. And I think all my queries are pretty basic and not too like involved. So it should be okay.
Great. That's all the questions.
Okay, great. So now we're gonna do something like enhancements to text. So the text here is nice, standard, but sometimes you just want to jazz things up a bit. So we have some ways to make that a bit better. So call them text tricks because there really are kind of tricks. You don't really know these things because they're just a little bit unique to this package, but I'll show them to you. So if you have links in your text, point blank will try to identify them and style them nicely. I think you've seen this before in a previous one of these. It just make a nice light blue color, underline it, that appears on hover. But basically you just create links like this and then it should work. Or you can create links like this with the square brackets and then the rounded brackets. You'll get the transformation automatically. If you have like things like ISO dates, it recognizes that. And if you put in parentheses, what does it do? It does something special. Let's see what that is. So I have one right here. Let's take a look at informant. And it's basically adding to what we have originally. So it's going to be like an addition to what we have. We're using incorporate at the end. That just means it'll just update. Okay, and now informant. Just hit up twice, sorry. Great. So see right here, we did this. We just had to enclose it with like parentheses. And if it's a date, it'll do this. Kind of a take it or leave it thing. If you like that sort of thing, it's kind of nice because sometimes you want dates to stick out a bit more. Okay, labels. Sometimes you want labels. So we can take portions of text and present them as labels. So we do that with double parentheses or triple parens. So this is pretty good if you want to signify priority, category, or some other information find useful. So you're just making your own little labels. So yeah, we're going to add on to the informant we currently have. Here we're doing something where we use tie select. Anything that ends with mm or ends with g, these are some sort of like measurements. We're going to call them measured. Additional notes, factor numeric integer. Essentially, we're adding some labels at the end in its own section. Let's actually run this and see what it does. Okay, here we go. We're going to have to scroll a little bit, but we'll eventually see it. Oh, here we go. So this was something that was measured, and we just put a little label there, measured. All we had to do was like include the word measured in double parens. Again, the text is additive, so it will be added to the end of the current text. So you just do stepwise. It's kind of neat. At the very bottom, we have additional notes, data types, and we have these really nice rounded labels like that. So factor numeric integer. Not that important in terms of like what this is, but it's an idea. It gives you kind of what you need. Okay, style text. So if you want to use CSS styles, if you know about that stuff and you want to use it, you can. So you have to use this construction right here. Info text in double square brackets, and then angled brackets doubled again with the style rules. So here's an example. The text, this is a factor, and the factor is enclosed in the double square brackets. And then immediately following that, we have some CSS rules. Now, important, it's separated by a semicolon each time. And then we use, proper CSS rules. Because we're generating this in HTML, totally not a problem. It just gets applied to those bits of text. Okay. Some ideas for text: color, just changes the text color. Background color, the text background color, basically. Text decoration and text transform, we can choose these options. Letter spacing can be changed. Oops, sorry. Word spacing, font style, font weight, font variant, border. So lots of different things you can change. These are just suggestions for obvious ones. There could be other ones too, but let's try a few examples here. So in additional notes, we have these words: penguins, Antarctica, measurements. They're actually like labels because we have a double parens, and we also have the double square brackets. So we're doing two things here. And here with factor, we're showing that example as above, except for changing we're adding an underline there. Okay, so let's run this. Great, is that updated? Oh, okay, so I'll just type this in. Okay, great. We'll have to go to the bottom, I believe. Well, actually right here we have, factor underlined. That's what we did right here. Great. And at the very bottom, keywords: penguins, Antarctica, measurements. We now have these labels, and they actually have a border color and a background color. This is really above and beyond what you may need, but at least it's possible just in case you do need it, because you never know. It's always good to have the option. Oh, wow, this really kind of ends it. Okay, so with the above info columns and info section function calls, we can style a single word with an underline and even style labels. Great. So to sum up for this section, you can create the table with the one being documented with an expression inside of info snippet. We can use various snip underscore functions included in point blank. They handle common use cases. We didn't show them all. We didn't show the stats one, but the help is there for that. Label like text, we can do that with double or tripled parens. And we can style text with this construction with the square and angled braces. Links are automatically styled. Dates, they could be auto-styled if enclosed in parentheses. So lots of options. I think that makes it look really good. There's probably too much to do if you do all that, but who knows? You may need it. So again, this whole thing is something that you can publish. That's the whole point. And currently we don't have a way to make this automatic. You have to sort of do it yourself, make your own sort of pipeline. But I can envision a system where you have a bunch of tables and you have a number of these and you just navigate to them. Okay, that pretty much ends it. I'm going to go to the chat and address any questions.
I think, Rich, I'm going to pick up one embedded a little earlier. I think his
Sure.
comments about the steps are additive. Can you undo the steps?
Undo the steps. No, you can replace the whole bit though. Basically to undo, you just don't write it in the first place, I suppose. Well, actually, no, you can sort of in a way. You can overwrite with nothing, I suppose. So if you do info text, info columns, I should say. And there's an argument in here. It's going to tab to it. It's called add. And it's true by default. So I can see replacing something that you just get a table and you have this thing in it, you don't want it. You can just do this. And the section name as well, because there probably should be a section attached. So section equals this. That should get you back to square one, I suppose. But there's no real function for removing it, removing a section. Although it's a good idea for me adding that.
I think one more question before you can completely catch up the Zoom. Can you please show an example deactivating a step in an agent validation test or report? Yes,
sounds good. I can definitely do that. This is great because there is time to do this. So I'll get one of the simple ones right here. So I'm just going to write like this. So it's actually kind of like this. Active, false. There we go. So this is kind of good if you want to just like run it, but not make it active. Say if something's changed, you just want to like, skip past that. Well, data changes for some reason. You still want to run the report. You can do that. Agent 1. Okay, and there are other functions for doing this as well that just, you can do it spot wise. Like, I think it's like deactivate steps, and you give it an agent 1, and you give it this, the I. So let's do 1. Now, if you look at it, well, let's do this. Interrogate. See right there, but I missed it. But it says right here, now we run it. Step 1 is not set as active, skipping. And we did these before as well. Steps 12 and 13 are not set as active because we manually did that when we set the step. But you can do it after the fact as well. You can just use deactivate steps. And you can also use activate steps to go the reverse way to reactivate them in a way. So yeah, that's totally possible in lots of ways. And it shows in the report as sort of like a grayed out row. Okay, so if this is for that, I'll go to the the Zoom questions. Text touch-ups, very cool. Thank you so much. Let's see. Please show us example. Yeah, okay, did that. So I think that's it. The rest are just like good words. Okay. Well, thank you for enjoying this. Like, I put a lot of work into this package. I will pledge to keep working on it. I mean, there's like a lot of utility that can come from like, having correct data or seeing what kind of level of correctness you have. So, pretty important stuff. Great. Yeah, and oh, excellent. Okay, sweet. Great. And again, I'm repeating this like I'm like a broken record. Any comments on the package? Any features you want? Make an issue. Start a discussion on the repo. I'm like all ears when it comes to that stuff.
So I work closely with Rich on the GT package, and I can tell you that what he's saying is very, very true. So he's quite engaged on the packages. So all right. So one thing I'll mention is I just put in the chat box for those of you that would like to get the digital credential for attending today and completing the session. When you exit Zoom, please keep an eye out for the survey. We'll ask for your information so that we can issue you the badge. For some people who just haven't seen it, so if that happens to you, just shoot an email to info@rnpharma.com and we can help issue it to you directly. But thanks again, Rich. It's been amazing seeing how much questions and engagement has been coming in. We'll keep the Slido up. And so, Rich, if there's questions there you didn't answer or questions you'd like to answer, feel free to continue to check that out and see what happens. But
yeah, I'll actually get on the Slido now.
Yeah,
yeah, it's great. Thanks for setting it all up. And
yeah, beautiful.
Great questions coming in. I love them.
Yeah, awesome. And so we also just posted some of the other information for you on the Zoom chat. So keep an eye out for the recording in the YouTube channel. That won't probably be for some time. It takes a little bit of time to get things edited and approved, but we do hope to post this one when it's available on our YouTube channel. All right. Well, Rich, any last comments or people on the bridge would like to ask anything? Feel free to go off mute.
Yeah. I'll be here if there's any questions, but maybe I have nothing really much else to say. Use the package, please.